you want me to talk? All right. Thank you, Rocky. All right, let's get started. Everyone in the back, hopefully you can hear me. Come a little closer. Amazing turnout tonight. Wanted to give a quick, huge round of applause to Google for hosting us, for feeding us, for live streaming us. It's an incredible event. So, round of applause for Google. All right, tonight's hashtags are here. There we go. All right, SFHTML5, perf matters. And wanted to also give a shout out to the folks from the Grand Eddy Winery that are in the back. Maybe a round of applause for them for all the great wines. And for Rocky for DJing this great music for us. He'll be back in the break. Thanks. Great. Okay. So, I should have clicked through here a little bit. All right. So first of all, want to thank you all for coming and say a couple of words about the sponsors that make these events, keep these events free and possible. Again, the first one, Google, actually specifically the Google Developers Live team, doing a great job. Jamie, Brian are here. They've been working for 4 hours to get the live stream going. So I also want to say hello to all the people that are watching live. Last time I checked, there was like close to 100 people live already watching around the world. So thanks to them for putting it on. The Google Developers Live, by the way, is sort of the Google Developers TV channel, if you will. If you want to know more about developer tools or mobile or Chrome apps, just go there. Developers.google.com/live is the place to go. All right. I wanted to let you know about a great event that is happening in November. It's called the Chrome Dev Summit. It's really a chance for you to connect with the Chrome engineers. It's going to be in Mountain View. Registration is going to open up in early October. It's going to be pretty limited seating, as usual, like 300 or so we can fit in. So registration will go out and sell out pretty quickly. But it's a great conference. We're also going to be live streaming that using the Google Developers Live platform. So definitely look out for that. There's a link there, g.co, Chrome Dev Summit. Okay. How many of you are new to SFHTML5? Okay, some of you. So we have these monthly meetings. We've had them now for like over 3 years. Every month, usually the last Thursday of the month. But we have like one of these big events every month. And we also host workshops and other events. And our next event will be all about WebRTC. Actually, it's going to be 2 events. We're going to have 3 talks about WebRTC. Chris Wilson is coming to talk about it. We have a guy from VLine. We have a guy from PubNub talking about data channels. It's going to be a great event, and it's going to be on October 9th. Actually, the registration opened kind of quietly. We didn't announce it to the whole group yet, so you can still get in. And you know that may be hard sometimes. So definitely sign up for that. We have that event. That's a Wednesday evening. That's not our usual Thursday. It is going to be live streamed as well. And then the Saturday following that, we have a great event, a WebRTC hack workshop. So actually come in, either run through a code lab or build your own WebRTC solutions. We have a ton of WebRTC experts from Google and other companies on hand to really step you through. It's a really great way to get into that. Okay. Wanted to thank Adobe, one of our sponsors. Of course, great and tools for HTML5. Great stuff they're building. They're extremely active on the web platform docs front, and that's a cause that's really near and dear to our heart. We really want to push that forward, get the right web documentation for all of the reference information of the web. Also, a great event coming to San Francisco in the Moscone Center. So it's now, I think, the 5th version of it, and it's getting bigger and bigger and bigger. It's the week of October 20th. There's a day of training, 2 days of full conference, HTML5 DevConf. I think most of you have been there. If you haven't, it's an extremely good deal, and 2 days of full-on conference followed by more training. So there's some great sessions. Anne Burkett is here. She can tell you more about it at the break. But basically, check it out, HTML5 DevConf. What's the date? October 22 and 23, and then around that, there's the days of training. We have a new sponsor, PubNub. They make software for real-time publishing and subscribing to data right in your application. They actually have like publish and subscribe as JavaScript functions, making it really easy to create real-time data feeds and applications around that. Bounty Source is here. They're going to be doing a little lightning talk at the end of the first break. So they'll come back, and they will also be raffling off some great prizes. And by the way, HTML5 DevConf will also be raffling off 2 tickets to the conference. And there will be 3 Chrome Dev Summit tickets. Peter, do you want to say a little bit about Kazing, one of our founding sponsors?
Sure, thank you. My name is Peter Moskowitz, and I'm here representing Kazing. Kazing has been a sponsor of SFHTML5 since its inception. Kazing has a high-performance, enterprise-grade, very secure, very scalable WebSocket server. We are a startup down in Mountain View. We have about 50 employees at the moment, and we are hiring very aggressively. So if you are interested in evangelist roles, you're interested in engineering, please come and find me. Thank you.
Ben, one of our new sponsors, Intel. Ben, you have a couple of words to say about Intel.
Yeah, hey, my name's Ben Odom. Just like to talk a little bit about our new XDK New integrated development environment for HTML5. Totally redesigned, browser independent, works in Mac, Linux, Windows. Totally free, has brackets integrated. We use Cordova 2.9, allows you to publish to pretty much every platform out there, Windows, Android, pick your favorite stores. You can also do web apps. So there's some cards over there that tell you where to get it, software.intel.com/HTML5. Take a look, give us some feedback in the forums, and we appreciate it. Thank you.
Thanks, Ben. All right, so we have Vitamin T here, special sponsor for this particular event. You want to say a couple of words?
Hi, I'm Glorianne, and this is Ariel. We are here from Vitamin T. So Vitamin T is a creative staffing agency. We're a division of Aquint, our parent company, which is the global leader in creative staffing. So what do we do? We help people like you find jobs, front-end developers, visual designers, UX designers. It could be temp to perm, freelance, full-time, contract, remote, offsite, whatever, you name it, we can help. So if you're on the market or if you have friends who are looking, please come and find us. We're in the back right next to the registration table. And also, a little surprise, we have a giveaway too. We're going to be raffling off this awesome GoPro camera. So please stop by, drop off your business card. If you don't have one, you can just put your name on one of ours, and we'll give it away at the very end. Okay, thanks so much.
Thank you. All right. One of our special sponsors for tonight is DICE, and they've actually, I don't know if you've seen it, the DICE Tech Trek bus is back in town. That looks like this. One of our members won this at a previous event and had a blast to basically be taken all through San Francisco.
Yes, that's right. So with dice.com, come and see us at our table. If you register with dice.com, even if you're not looking for a job, there's all kinds of great stuff on there. You can get a T-shirt, you can get dice pens, but we're going to be raffling off a couple of things tonight. One with you guys and one over here back at our table. But we've got the K-Cup coffee maker. But the best thing is an all-expense-paid tour tomorrow night for you and 2 of your friends, and we're going to take several winners, and we're going to go to dinner and dessert and a bar, and we pay for the whole thing. And the bus is amazing. It was Lenny Kravitz's tour bus. Now it's the Dice bus. So come check it out on the way out, and we'll stay around for a while afterwards so you can register at the table and go check out the bus.
Great. Thank you. All right. All right, so hopefully you all have a raffle ticket because we have some great prizes tonight. We have a Chromebook Pixel, some of these sponsor prizes. We have wine from Grant Eddy. There's actually 2 raffles for that. There's regular raffle wine prizes. If you want to increase your chance for more wine, drop off your name for their mailing list, and you'll get an additional chance to win. All right, so okay. That's it. All right, I want to hand it over to for the first speaker. So I'm really excited about the 4 speakers we have tonight. Actually, Jake and Paul came all the way from London, and we said, wow, this is great. You're in town. Colt and Paul are already here. Let's do a performance talk with 4 speakers, and really excited. The first speaker is Colt McCandless. He's a past speaker. He's one of our alumni. You know him from the Udacity study group that we've hosted here. If you're not familiar with that study group, or if you're not familiar with the HTML5 game programming Udacity course, definitely check that out. We did this 8-week study group here, right in the Google office, actually. So I want to hand it over to Colt. Colt is a developer advocate at Google. He focuses primarily on performance, and a round of applause for Colt. Do you need this one?
Can you switch over to my slides real quick? Hey, real quick, everybody, you have no idea how hard it is to plan one of these events, put it together with all of us crazy people, as well as the catering and the prizes. Peter Lubbers and Vanessa and everybody involved with this meetup has done an amazing job. Can you give them a round of applause for free beer, please? Yeah. Yeah, I got a mic. How am I doing on the live feed?
You want the podium mic or the handheld mic for the room?
Okay.
Okay, great.
How's that? Can you hear me in the back? No? How about now? Up more? Up more?
1 second. We'll fix that.
We make self-driving cars, for serious. We can do this. We can do this. All right, we good? In the back, up, down? Middle, down, bald? Someone said I'm bald. That's not cool, dude. I saw that. All right, we good? No, maybe. All right, I'm just going to keep talking. How about that?
Yes. Brian, do we need to turn it up?
I agree, we can get it. How about we do,
Well, here, maybe we can go.
maybe? Testing, testing, testing. Put that down, this down. I don't know. How about I do the hand mic? How about we do that? How's this? How's this? This is better? How come when you get a mic in your hand and you're in front of people, you just feel sexy? You feel like you want to talk to you, and feel your pain, right?
Good. All right.
If there's anything I can do, it's entertain a crowd for while technical problems are going on. Yeah, all right, my turn. Fantastic. Hello, everyone. My name is Colt McCandless. I am the team lead for the performance section of Chrome Developer Relations. And tonight I want to talk to you about the joys of static memory JavaScript. Now, I'm going to let you know that I gave a great talk at the HTML5 DevConf early this year in April, and I had a little section in my talk about static memory JavaScript. And bar none, the most questions I got was about static memory JavaScript. And so I actually went back and actually wrote this presentation a couple months ago, and I was very happy that Peter allowed us to do it tonight. But it was really interesting because when we tried to get this thing together, it was like, really, it was a one-off shot, right? Like, we had to get the guys from Europe in town, and they only had availability for a window, and then we had to figure out like what day of the week we had availability for like Google's facilities and catering and all this other crazy stuff. And it was the most random shot in the dark for us to end up on September 19th. Now, I'm in a room full of nerds. Does anyone know what September 19th is? Yar. Now, I'm a very simple man. And I had to stand in the mirror a couple days ago, and I had to ask myself how much of a man I was if I could take this opportunity to give a talk on the most random shot day, to be able to give a talk in front of a room full of my fellow nerds and actually do the entire thing as a pirate. My wife didn't believe this was possible. I showed it to her on Google that this was a thing. And so I'm going to ask you tonight, can we do this? Listen, you bildrats. I'm asking you, can we do this? One more time. We've been giving you free booze. Give it to me again. Now that's the crew I be looking to have tonight. Aye. Now tonight we be talking about one thing in common. We be slaying the waste monster. Its vile tentacles be keeping your applications from going too fast. I lost my leg and got a new one. That's why I hate it. My name is Captain Mainroach, and I'm here not to save your bodies, because the monster be taking those. I'm here for your souls. Well, the application souls really don't care about you, but we need a refund on the... I'll get to my point. If you be hearing anything from Captain Mainroach tonight that you want to be tweeting, make sure you be using the right hashtags, because we had those back in the day. And also be making sure that you visit our web performance group on Google+. It'd be a great place for a bunch of mutineers? That came out wrong. All right, this is a little well rehearsed. Make sure you visit it. Sign up at goo.gul/webperf. Now listen here, you modest yellow-bellied dogs. I'm not here to listen to you wallow and wane about whether or not you like the JavaScript garbage collector. I'm here to tell you that it be a vile beast that be taking everything from you. Because as it does its evil task, it's going to be taking away a little bit of your frame rate every single time. And I'm not here to debate your dogma. I don't care what gods you live to. Be that of managed memory or static memory or dynamic anything else. I'm here to worship one God alone, and that be the one of application speed. Can you say R? R. One more time, R! R. Hey, application speed. So stow your noise tonight. I won't be debating whether or not JavaScript's the best language or the worst language, but I'll be telling you how to make your applications fast, because that's why you're here. Aye? Aye. You're learning. That's good. So I'll tell you the trouble with memory. Now, many of you may not be versed in the wild seas of sailing around memory problems, but I tell you, I've been there. I lost my hair and my family. It'd be a vile place to be. From the depths of hell, memory management come and it take you. It take everything in your life. I'm here but a husk of a man, trying to make sure you do not follow the same path. Let's tell you why. So when you're out sailing with your buccaneers, having a good time writing your web applications, sooner or later, one of you is going to drop dead. In your web application, one of them will be running around, allocating memory or adjusting the DOM, and sooner or later, it'll have one too many pints of beer and die. We're pirates, it happens. But now I tell you this, its corpse won't go away. No, your crew have better things to do than remove it. Instead, you'll leave it on the ground, festering. When the rats come and pick at its bones, and the gnats come and lay in its eye sockets, and the gulls come and feast on its flesh. And only then, when the monster gets a whiff of the piles of corpses that you've been leaving around in your application, only then will it summon its bulbous arms to your poop deck. Poop deck joke, that's good. Poop deck, more poop deck jokes, okay. And when this beast come and find your vessel, it doesn't know who is living and who is dead. It's a blind beast filled with hate and rage. It'll bring its tentacles up aboard your vessel, and it'll sniff every one of your crew to figure out which one be inactive and which one still be on the stack, ready to be used again at a future date. And when it finds its evil prey that it be eaten on, it'll take it away from you. And only then will your dinghy be operating at peak efficiency, now that all the corpses have been hauled away on your behalf, you lazy captain. But I tell you this, the beast takes away as much as it giveth. Because your schooner be going fast on its mission. It be hitting 60 knots per second. Everyone knows that's the magical speed of a boat. And as it be going at 60 knots per second, all of a sudden those piles of corpses will rise high, and you'll hear it. You'll hear the vile beast coming from afar. Its hate and its dread and its demon-filled life coming aboard your vessel, and it'll stop you. And it'll take away those knots and stop you to zero. And all of your men aboard your ship will stand there idly and wait for it to do its demon-filled task. Meanwhile, your users are standing there asking why your ship is not moving. And you can't be like, it's the monster, it's not me, because they blame the captain. And then you get fired and you have to talk like a pirate all day. And when it's done with its deadly task, it'll let you on your way, only to catch you again in the future. This be the cycle that it lives and breeds off of. Your reluctancy to allow the corpses to lay around because you've got better things to do, like CSS. Or I be a ventured pirate from back in the days of C++, where a man had to manage his own memory and his, Stack Overflows and threading problems and kernel issues, but that'd be a simpler time then. We didn't really have user interfaces back. It was mostly a command prompt. Moving on. And what you be needing to know is that this monster can strike at any time it chooses. It doesn't matter what you think it should be doing, it's going to do what it wants. Being a callback handler, or when the frame is updating, anytime your JavaScript-style dinghy be floating on the water, it'll rear its ugly head as it sees fit. And you should know that the most important thing about your vessel is that it stays constant at 60 knots per second. It doesn't care what you want. It cares for the flesh it's come to claim. Aye? Aye. I see some scared in the house. They're like, where is he going with this? Are we talking about memory or fishing? I'm really unclear right now. Don't worry, it'll come down. Now, here is a great chart, lads. Your yellow-bellied seabetters may be looking at me and going, listen to this angry man. He'd be thinking garbage collection's a bad thing. I'm a friend with that beast. We go drinking on Friday nights. No, it is not your friend. It's just using you for free drinks on Friday nights. I'd been there once. I will talk about that later. If you get nothing from me diatribe this evening, I want you to be remembering this one. This is a map built by the most evil of satanic of scientists that follow this beast around. And what you'll be looking at here is two distinct groups of lines. The first group is done by the responsible captains who send their crew to the evil task of managing the dead themselves. Now, it does take a little bit more memory for the captain to ensure that the crew is doing the right thing, tossing its shipmates overboard. But you can see on the other side is the one where the Kraken, the evil corpse monster, be doing the work for you. Now, these lines mean nothing right now, but I'll tell you what they do show. On the bottom line here, these numbers chart out how much memory the system has relative to the application that be running. Oh, for your nautical folk, how big the sea is compared to the size of your ship. Aye? 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 Aye! More beer, aye. Now, what you be seeing here is three distinct areas that I wish to be pointing out this evening, because you'll find the treasure soon, hey? First is you see the bad zone. If your memory is between 2 and 4 times the size of your vessel, ye be screwed. You want to know why? Because this Kraken beast, this hate-filled, demon, vile-covered spawn monster be larger than you think. And when the body of water that your schooner be floating in be small, it has nowhere to put its hefty load of lard. So it must put it upon your vessel, all the way on the poop deck. You asked for more poop deck jokes. I'm going to give them to you. You have to laugh now. Yeah, you're pretty laugh. Now, when you end up in this second region here, you're doing a little bit better. You can see that 4 to 6 times the size of your memory requirements you be about average compared to what your crew be doing manually. This is about the sweet spot on mobile devices today. These little devices that they have that track all of your movements as you're going about, eating your food and plundering and pillaging in all your pirate ways, right? This is where you be sitting with your memory. But unfortunately, that's not where the sweet spot be for your vessel. Nay, your ship needs to be in a wide open ocean between 6 and 10 times the amount of memory that your application be needing. And it's only then will you start to see the hate from this vile corpse monster actually be mitigated. Because the water is able to hold its massive rows of flesh-eating, corpse-filling, bile-drinking fat. Unless you're here, you be screwed. So make sure that your JavaScript class schooner knows what the size of the water be going in. If you remember nothing, remember this graph tonight. Arr. Arr. Now I will tell you, there be one vessel on the 7 seas that seems to escape the corpse monster many times. And in fact, many have said that it be the fastest JavaScript vessel in all the world. It's known as the SFHTML5. Do you know the vessel? Aye. I said, do you know the vessel? Aye. Aye. You want to know why it's so fast? Because its captain is damned. Aye. Everyone's really confused right now. Is this an open source boat that we're talking about? Because that means lots of people are damned. Open source boat, that would be interesting. That's a new Kickstarter. Yarr! And the reason that captain be damned is because you know what he does. He doesn't let his crew die. Nay, when he sails from port, the first evil action he be doing is he slaughters the lot of them. Slits their throats standing on the deck and let the blood flow across the planks into the water, where the sharks be feasting and the gulls be squawking and nesting. And you know what he does? He brings a single shaman on board with his deck. And that shaman doesn't let these poor men die. Nay, he keeps them in some trivial state of not dead and not living. Not dead enough for the corpse monster to come aboard. He manages the dead objects on his ship. Yar. Is anyone getting that yet? Okay. And what he'll do is he'll summon a corpse as he needs it and revive it, and then send it back to dead by slitting its throat again. Aye, this be an evil captain, but what he does well is he escapes the Kraken monster once again. It can never seem to catch this SFHTML5 because it can never find it, because the corpses never rot and ripen. You see, this evil, bile-flowing, covered with boils and rank and fester and alimony taking... Okay, so I feel I should tell you something. It is true, the monster and I were once in love. You see, I was a young buccaneer and hadn't seen much of the world, but you know, that we grow and we change, and the monster and I parted ways. But we're not here to talk about me tonight. But he does take half of me doubloons every month. My job tonight to be keeping you away from the path that I be taking and teaching you how to use the techniques of the SFHTML5 to keep your dinghy moving fast. So we'll start with your own concept of a corpse pool. So when you be getting your mates on your vessel, make sure to slaughter them thusly. Usually across the neck works fine. If you get any fancier than that, it's just showing off. I mean, really, come on. We be pirates, we simple folk. Now, when you need a task done or you need a crewman to achieve a goal for you, the best thing to be doing is reviving him. Use your dark magic. And what you need to be doing is, you need to remember that this corpse, it has the memories. It remembers who it used to be. So when you grab it off its corpse pool, you need to give it new clothes and set its properties so it cannot remember who it used to be, and instead assumes the goal you want. And when you have a demon-summoned, dead-filled, evil corpse to do your bidding, you must usually make sure that it follows that path. And it does the most evil, heinous thing that you can task it to, generally making the world a worse place for common folk. Take a second to let that think in, a zombie on Septat. Yeah, that would get very awkward very fast, yar. And when you're done with it, much like the SFHTML5, you slit its throat and put it back in the pool and let it float away. Again, this will keep the Kraken monster from actually coming to board your deck and taking away your speed. And this is some hieroglyphs from an ancient time, but I'll walk through them anyway because I happen to speak it. So you can see that to use such a thing as a corpse pool, the first thing you need to do is actually grab a corpse and revive it, and then set its properties accordingly, like, you know, where it will spawn in the universe are. Do a jig, walk the plank, and then when you're done, slit its throat, throw it back on the pool, and then make sure that any clothes you may have assigned to it, you cast overboard to Davy Jones' locker. He happens to sell things out of the locker, that's why it's a locker. It's actually a second-hand pirate store, see, that's where we get most of our clothes. what will happen is when you use this sort of pattern of corpse pools or object pools, what you'll be seeing is that your memory will slowly grow over time. It'll be riding a wave that will never end and your ship may never come back to shore. It'll just slowly be increasing. Now what you'll notice though is that you'll be spending a lot of time in here, moving between all these ranks. And it's worth noting that under the hood, JavaScript may be doing something that ye not be planning as captain. And as captain of your vessel, you're in charge of its fate. Aye? Aye. It's not in charge of your fate. It's a boat. You're the captain, aye? Aye. So don't let it do what you don't want it to do. Arr. Do you know under the hood what happens when you have a pool of corpses and you add another one to it? Well, if you've actually maxed out the number of corpses and you add a new one, you know what your boat be doing behind your back? It'd be creating a new pool of corpses double the size. That takes a lot of extra memory. I don't know how to say that in Pirate better. That was a little failure. That's okay. We're doing this on the fly, arr. Now let's say you continue moving forward again, and once again you get to the point where instead of 200 corpses, you added yet another, and then you have to move to 200. To 400 corpses you'd be moving to. Now, what is interesting about this is that every time you add a corpse to the pile, your ship have to go back to bay and make more room. You need to make changes to your hull to accommodate all the corpses you'd be having laying around. But once your hull has been destroyed, you have to rebuild it. So you have to deallocate the previous array in order to make room for the new one. This creates more waste for the corpse monster to come and fester and bleed and take away from you. It's be taking your time, lads. It's not a good thing, arr. Oh, you're getting bored now. Arr! Arr! Don't worry, there'll be more booze soon. Really, what you need to be thinking ahead, as the captain of your ship, how many dead corpses will I need to get this job done? Yar, tell that to your manager. That be CEO level thinking there, yar. Yes, yar, you see, we can't ship a self-driving car, but how many corpses can we fit in it, yar? I guess that's a question you ask in Las Vegas, yar. Some people got that. So what you need to be thinking of is how many corpses you need. And instead of actually going back to harbor many times and rebuilding your ship and getting more corpses, instead, you need to think ahead and hire the corpses and kill them ahead of time. And the question that you have as simple pirate folk who are very bad at math is how do you determine the number of people you'll need for this evil task you be setting forward? And mostly how many knives will you need, because they kind of dull over time. Now the proper way to be doing this is an iterative testing loop. Again, that really didn't translate to pirate. Just follow with me. It'll make sense in a minute. So as your ship be going out, you need to be running tests. You need to run through what you think the average duration of your journey be. And you need to be figuring out how many corpses you be needing over that time. And every time you adjust and change and rebuild your ship. And as you be doing all this, you be remembering or logging out what your maximum number of corpses be, or your average number of corpses, or how many of them are bald. And you be telling me, because then I'll be upset with you. We're mostly discriminated against us bald pirates. We don't have the facial hair, and so we can't go to all the parties. Yeah. Once you have been done through this process, and you remember how many corpses ye may need for your final journey, only then can you embark. And when you do your final journey, you'll know ahead of time how many objects to reference and keep, and how many corpses to slay. And what we'll end up seeing is that your memory profile will look a little bit more stair-like. Yar! Yar! And the number of corpses you need will statically decrease. And you need not to go back to the harbor so many times. That means you stay on the water longer, and you stay faster more often. Yar. The wind in your sails be the best one of all. Yay. Now, sooner or later, you're going to need to slit yet another throat, even though you've pre-allocated your corpses. And when you do this, you need to be thinking back about what your ship be doing without your knowledge. Will you let it go ahead and double the arrays every time? That was the most awesome response. Yar? Nar? Nay? The best was I saw one guy over here look at his buddy and go, Yar, nay, nar, no. What if we just say no? You think he'll point us out? Quit talking, he's looking at us. The answer is nay, you not be letting the ship do what it wants. You're the captain, you make the rules. Yar! And instead of allowing it to double in size every time as your application needs it and your DOM changes and your objects move, instead you be using what we call a linear growth array, where instead of actually using the standard array object, ye be using a linked list of typed static arrays. So as you add a single object, rather than doubling the size of array, you only increase it by certain amounts. You can be 100 corpses, or 1,000 corpses, or a platoon of corpses if you choose. Either way, they're the king's men and they're free. Sorry for the British in the audience. Yes. Now, the linear growth array actually be good because you'd be amortizing the cost of the corpses over many, many corpses. So every time you allocate a new array, you're actually amortizing the death of all those because you do it once. It's tricky pirate math. Lookup be easy to do in this structure. You can simply index into it with a little bit of magic and fluff and dust. You be finding what you need. However, deletion damn near be impossible. I do not recommend that. Don't do that during a job interview. It will reflect on you badly. I'm not saying I've done that, but do not try that. The point here be that this is an app-suited container for the growth of static corpses on your vessel. It allows you to grow, it allows you to pre-allocate, it allows you to stay fluid when times change, yar. And that's be the pirate way. Now, for all of you in the audience, you may be saying to yourself, I have no freaking clue what my memory be doing. Yar? Yar, welcome aboard, mateys. That was the most hearty yar. Yes, I have no idea what you're talking about. I am so lost right now. Thanks for playing along, lads. For those of you who be looking to understand what's going on under the hood of your deck, you need to be looking at a couple of tools. To start off, stick with Chrome Developer Tools. It actually be giving you a pretty good understanding of how many corpses and objects be used along the duration of your trip over time. And with new tooling on the bottom, it'll actually tell you what heap these corpses be coming from. Be they the audio heap from the southern regions of France, or they be the rendering heap from Jamaica. They be a spicy lot, lads. Anyhow, stop here. Make sure you run your application through the tools, figure out where your memory is going, and adjust accordingly. Ye be the captain, aye? Aye. Another great tool that's just come out. However, the shitty picture was all I could find on the internet. Because for some reason, they don't have anyone who could put up a more high-resolution photo of the damn tool. There's a good tool called Adobe GC View. And no, I couldn't get it working, so I couldn't take the picture myself. Yar. This is a fantastic external tool that will allow you to do memory profile analysis from multiple different browsers. Yar. So for those of you out here who may be saying, oh, Captain Mainroach, you're kind of off the plank with Chrome only, check this out. But seriously, put up a better picture. That's kind of embarrassing. I'm a pirate and I'm calling you out, yar. So lads and lasses, my crew tonight, thank you for listening to me. Let me give you some tips on how to avoid this evil building mulch monster. First off, know that this monster be eating away at the speed of your ship, and that not be good. If you don't see the garbage collection be hurting your frame rate, you're not trying hard enough. Build a better application. Yar, I'm calling you out, yar. Yar. T-shirt for that man. The rest of you, to the planks. High corpse churn summons the monster. If you be moving lots of objects around and not doing your duty, then the corpse monster will find you. It'll slow down your vessel, and then you'll be cursing all day long, and I will be sitting back laughing. Kill your crew before you sail. Sail them as zombies. I dare every one of you in here to tweet that right now. Kill your crew before you sail. Hashtag perf matters. The bald pirate told me to say it. I'm not crazy. Know your corpse count by testing your voyage ahead of time. Be the captain of your vessel. Don't let it control you. You're in charge. Yar. Yar. That one hurt. Hold on. Oh. Too many. I need to stretch my yar. When you need more corpses, make sure you linearly grow. Don't allow the ship to do it. You do it yourself. In honest, I missed the corpse monster. We did separate, and there were little ones involved. But you know, we'll be back soon. You know, with the new primitives in C++11, there may be a chance to get a better high-performance allocation system where I may not have to manage my memory myself. That's a separate discussion. Anyhow, yar, thank you all for listening to me tonight. And I'd like to remind you that we won't be taking questions now, but we will be doing it at the end of the night in a fireside chat manner. Yar, thank you for listening tonight.
Thank you, Colt. All right, Colt, we have a special gift for you, Yar.
Thank you.
There you go.
Another round of applause for the great SFHTML5 team Yar.
All right, so for the next talk, we have Paul Lewis. He came all the way from the UK. And he's a developer advocate on the Chrome developer relations team. He's specializing also in performance, knows a lot about WebGL, and been just great working with Paul for the last, about a year now. So Paul, are you mic'd up already? Okay, great. We have your laptop here. We'll just switch over. Oh, the same? Yeah, okay. Yeah, we're switching over to laptop. Like I said, we'll have one more talk. Then we have a pretty good break for about 25 minutes. We'll have more time to hit the different sponsor booths and so on. There's wine and there will be dessert as well. So let's just switch this out right now, and then we'll have plenty of time for a break. Again, a couple of great raffle prizes, conference tickets, and a whole stack of wine and so on. So hang on to those raffle tickets. We'll have 2 more talks after the break, and then we'll have a Q&A panel. So we don't take questions right now. We'll just wait for that at the end, and we'll just pass the mic around the room. Okay. All right. So one moment. So it doesn't fall. Okay.
Yeah. All right. I'm good. I'm good. You all good? You can hear me? Yeah? Yeah? All happy, huh? Now you may be noticing that today but I think not. But what I thought I would do is I thought I'd take a step back for us now, and I thought I'd visualize the speakers for you by help of a trusty Venn diagram. Now, on the left, we have bald people. On the right, we have Pauls. Colt, firmly in the bald camp. Professor Irish, firmly in the Paul. Me, making up the middle. The intersection, if you will. But unfortunately, we have Jake, who's thinning up top and trying to get into bald. I wish him well. Now, what I wanted to do is I want to kind of set the scene, and I feel like resetting the scene. Talking about rendering performance, there's a lot of people that kind of go, oh, I'm not so sure. What does he mean by rendering? There's performance chat, and what we've done, I think, is we've gone, okay, how long does this thing take to load? How many requests am I making? Have I got gzip switched on? What about e-tags? They're dead. I don't know what to do. And I think I understand why we've done it, but the thing is, it's only part of the picture. Okay, it's only part of the problem, because as we discussed with, or Colt discussed with the memory thing, that's something that doesn't fit into page load time, right? And that's a part of performance. So it's sort of a bit of a question. And so what I thought I'd do, just a quick, highly technical graph or chart for myself of 2 apps. App 1 is fast to load and slow to render, and app 2 is slow to load and fast to render. And which is worse? Which is better? Well, the answer, of course, is both of those are going to hack off your users. They are not going to be happy with you, so it matters. So what I thought I would then do is take us through the pipeline, a little bit like this. The idea here is I'm going to, from a page load perspective, because that means we'll hit every part of the pipeline, I want to get through from how the browser does a request and gets pixels onto the screen. That's actually the job of the browser. It's there to get content on your users' screens. So it's good to understand it. And then when your users are scrolling and dragging stuff about and just generally using your site or your app, then we'll hit parts of this pipeline again. So it's good to understand it. And it's sort of, this is part 1 of 2, because I would normally talk about the dev toolsy part of this, where you can figure out how your project is actually working. But Paul Irish is going to actually do that part later on. So think of this as a sort of scene setter, a part 1, if you will. Now, we start off our journey with the humble GET request, like so. Our server is going to respond for us with some HTML. All pretty awesome. And the first thing that the browser is going to do, and it does clever stuff with doing streamed and look-aheads and all this kind of stuff, but it starts to parse that, and you see, when you look in DevTools, you'll see things like parse HTML, which is this process, really, of taking our tag soup and turning it into this, which is the DOM. And that's the DOM for that HTML. So we'll just make our lives a little bit easier and just call it the DOM. And then what we do is we take the CSS, and we're just going to add that plus in there. We take the CSS, and some of that CSS will come sort of part of the browser. There's the default style sheets that with the browser. There's the stuff you put in line. There's the stuff that's in your style sheets. And we start to actually figure out from the DOM what CSS applies to what. And historically, people have spent quite a lot of time trying to optimize CSS selectors. How quickly. And it's actually a bit of a waste of your time, because the browser is very, very, very fast at doing selector matching. So just bear that one in mind. Anyway, this will show up in DevTools as recalculate style. So what happens, and I'm about to do a sound effect, I can feel it coming along. We put these together like that. And we get the render tree. Paul Irish is happy with that noise. He's happy with that. Now, the render tree looks distinctly like the DOM, except that things are missing, like the head, for example, or our scripts. They're not there, because we're not going to render them. So they don't appear in that tree. But let's say, for example, I decide that in my style sheets I'm going to put section P. Whoop, I'm going to say display none. That will disappear from the render tree because it's set to display none. It's not something we're going to draw. It's not something we care about. Equally, I could have a pseudo element, and that would add something into the render tree. So the render tree, as I said, it looks like the DOM, but it's not the DOM. It's the styles applied to the DOM. So that's that. Now, the next job, and it's going to look like a really simple job. We've got all this CSS that we want to apply. And it's basically like widths and heights and display block, position absolute, all this kind of stuff. And what the browser has to do is take that and go, where does everything live on screen? What are the boxes here? And as you probably know, this can actually get extremely expensive, because everything tends to be contingent on everything else. So if I were to change the height of body, everything that's inside body needs to be recalculated. And this will show itself up in DevTools as layout. And yeah, that's where all those boxes are coming from. Good. So the next job that we have is to actually fill in some pixels. We know where those boxes are, but they now need filling in with pixels, so we need a rasterizer. Now, just a bit of terminology in case you don't spend your time looking at this stuff. Vectors are basically sort of shapes that we have the mathematical formulae for, or we have the positions of the corners, for example, in the case of a triangle. But we're interested in actually pixels. So what we actually have to do is we have to figure out from our triangle which pixels we need to fill in and what color they need to be. And this is the process of converting vector to raster, okay? All pretty simple. Now, if you and I were to have a fun afternoon and we were to create a rasterizer, we'd probably include methods like this. And I know that we would, because these are the ones from Chrome's rasterizer, which is called Skier. And so you imagine there, draw points, draw ovals, draw rectangles, draw bitmaps, draw some text. You know, and if you've worked with the HTML5 canvas, a lot of this stuff will actually look quite similar. It's the rasterizer, basically. So now what we can do, I actually ran that HTML. I actually ran it through Skier and said, what did you do? And it told me. So I thought I'd show you what it does. Ta-da! But you probably didn't see what was going on, so why don't we have ourselves an instant replay? Now, you'll see that as we get through each of these calls, we're starting to build up the picture of what's actually going on. Draw a rounded rectangle, which isn't that clear, but that's the drop shadow. Draw the path. Here we go. Draw the bitmap, which is my face. Do a bit of tidy up, and we'll call it a day. DevTools is going to show you that as paint. That's how it goes about letting you know that it did some of that work. Now, some of this bears a little bit more scrutiny, I think. Specifically, draw bitmap. Now, I was a good developer. I sent through my tiny JPEG. I compressed it. I'm good on the page load time. I'm happy. Well done me. But you'll notice that it's called draw bitmap and not draw JPEG or draw ping or draw GIF. GIF. Hands up for GIF. Ooh, it's going to be close. Hands up for GIF. You're wrong. They're not graphics, are they? All right? Anyway, so now we have our JPEG, and we basically go through, and we're going to decode out an image into a bitmap. Red, green, blue, and possibly alpha. But the thing is, we're also maybe doing a bit of responsive web design, so we also have to do some resizes as well on the other side. So these are extremely expensive. They show up in DevTools. You can spin down paint records, and you'll see image decodes and image resizes, and they will kill your frames per second if you have them, particularly resizes, actually. Okay, so we've spent some time with draw bitmap. The next thing we want to look at is, we're quite fancy. We're going to do a bit of animation. What we're going to actually end up doing is we're going to move that picture of me up to there. Now, when this happens, we basically took this rectangle around everything and said, this is now damaged and dirty. This area needs fixing. This needs repainting. So we actually have to step through one by one and rerun all those commands with the drop shadow and the white box and the bitmap. And it doesn't take much imagination to figure out that if we have a lot of things that need painting, or we move something a really, really long way, that could be a hugely expensive thing that we just did. So what we do to work around that is we do these things called layers. Instead of having one surface that we render into, that we rasterize into, we have several. So this is my website, and this is actually, the masthead thing is a canvas. So why don't we just boost that out a little bit. Now what happens is we can basically do this so that when we want to change something in the masthead, we don't have to worry about the thing, repainting the thing behind. We keep it separate. This is extremely useful. What's also interesting about this, or at least to me, because I'm a nerd, is the next and previous buttons are actually DOM elements on their own, right? But they're sitting on top of something that was just boosted out to its own layer. So what Chrome actually ends up doing is it ends up creating more layers just for those. So you actually end up with 4 of the suckers. And these all get sent across the GPU, which we'll talk about in a second. And then composite layers is what you're going to see in DevTools. That's when it's taking all these layers and all this stuff, and it's basically going, putting them all together again. Figuring out what layers it needs, you know, where they need to live, all that kind of stuff. So those are the layers. They're pretty cool. And you might be asking yourself, I hope you are, how do I get a layer? That's exciting to me. You'll notice it's subject to change because it's an implementation detail. But all the same, let's have a look at them. 3D or perspective transform. Anybody use the null transform hack? Anybody translate Z happy? Yeah? Work for you? Good. OK, that's the classic one. Video elements, canvas elements, composited plugins like Flash or Silverlight, an animation on opacity, interesting, transform, filters like blur and all those ones. And then the last one, which is my next and previous buttons, those are rendered on top of an other layer. So those are the ones. You could imagine that we might add some more. We might. So the last little part, and this is the website from tonight, is to actually take those rastered images and send them across to the GPU. Now, the thing to bear in mind, all that rasterization that we did was done actually on the CPU. And when we do rasterization, this is a small detail. I just wanted to include it for completeness' sake. We actually rasterize into tiles. Doesn't make any difference to us as developers, but it's always, I just like to include it. I don't know. So there we go. That doesn't matter for what we do. But we have the CPU. All this work so far has happened on the CPU. So when people are talking about hardware accelerated this and that, so far, everything we've done was on the CPU. The last thing that we actually end up doing at this point is sending those tiles across to the GPU. Happy days. And that was a nice simple animation, but the bandwidth between CPU and GPU might be quite constrained, especially on a mobile device. It's very easy to saturate that link. And you can, if you're having to send across, if you're doing a lot of repainting, you're sending a lot of stuff across to the GPU, you might really struggle. So it's a finely balanced thing. Anyway, that's going to show up as composite layers. And finally, whoosh, there we go. We end up with something on screen. So now we know how you get from the humble GET request all the way through to some pixels on screen. So with that said, I am now interested in the bit where we control the workload. I really want to ask, are you the captain of your ship? But I'm not going to. So, but we are, and so seeing as we're in control, let's talk about some millisecond stuff for a second. Let's frame what we're interested in. When a user interacts with your site or your application, we have 100 milliseconds in which to respond for that user to feel like it was an instant response. If we take more than 100 milliseconds to respond to the user's interaction, we have failed. They will notice. The second thing that we care about is 16 milliseconds. If we're doing anything like scrolling or dragging or anything that's regularly animating and updating the screen, we have 16 milliseconds in which to get all the work done. Okay? So this is just to frame our argument here. Response time, 100 milliseconds. Frame time, 16 milliseconds. Okay? Bear that in mind. Now, all I'm going to do at this point, as I said, normally I'd show you some dev tools, but I'm going to just talk about some stuff you want to look at, some stuff you need to be careful of, and then Paul will actually run you through dev tools and the tools that are available to you. Small style changes can have big layout knock-ons. If you're, say, changing changing body, like I explained before, we have to relay out everything. Huge deal if you're trying to do that in an animation, for example. You decide you're going to change some high-level element, like sort of 1 or 2 levels into the DOM. Everything's probably going to get recalculated. That will kill you in terms of your frame rate. This is something of a common misconception, that layout is somehow triggered, always triggered by JavaScript. It's not. You can have a transition that's in response to a hover. It's not done by JavaScript, but it's layout all the same. And layout isn't painting. Now that you've been through that pipeline with me, again, there's often a misunderstanding that layout is somehow painting, but actually layout, if you do change the position of something, we might need to repaint. And we'll have a look at something that's doing that in a second. There's a thing that looks a little bit like this, and the code is, it doesn't really matter too much what the code's doing. Well, I'll tell you what it's doing anyway, just for a laugh. We're going through some paragraphs, and we've got some other element that we want to match the widths of all our paragraphs to. So the first thing we do is we ask for the width of this thing called green block, and we ask for its offset width, which causes Chrome, and in fact any WebKit or Blink-based browser, to go off and do a layout operation, go, what's the width of the green block, please? And then we set the first paragraph's width, and then we go through that loop over and over and over and over and over again. And that is effectively read, write, read, write, read, write, read, write, read, write. And that's not a good thing, because every single write invalidates the previous read. This is called layout thrashing. You do not want this in your applications. Okay. What you wanted to do, there we go, was to ask for the width once. Read, write, 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 write. Happy days. Paint. Show you this demo. Right. There's this brilliant tool called Show Paint Rectangles. If you're ever wondering whether something's painting in Chrome, that is your tool. And what's going to happen is, see, I select some text, right? And you get this red box around it. And that's basically Chrome saying, I had to do some repainting here. Paul, thanks, Chrome. I expected you to do it, and you did. You're so reliable. Anyway, so what I've got is I've got these buttons. Oh, yeah, scroll bar. That's getting repainted. Now, I've got this button up here that says animate. It is a highly realistic animation. Look at this. Now, the interesting thing here is that this one big area needed repainting. because we're moving everything inside. But we can also figure out that they've all been flattened down to one surface, one layer that we're actually painting into, right? So this is the thing that's getting invalidated. It needs repainting. That might be slow. So we're quite smart. What we want to do is we're going to use the translate Z hack to isolate all those boxes, and all we're doing is moving them around, and the GPU is really good at just moving stuff around. It's fantastic at it. So we're going to do that. There we go. Change them to black just so it's a bit easier. And then moving, you'll see we're not painting anymore, because we painted them once, all these layers, and then we just asked the GPU to move them around. This is an awesome way of using the translate Z hack. I've come full circle. I used to hate it. Now I love it, just for this reason. The danger that we then have is, I'm just hovering over it in this, animate the radii. Now, these boxes have a slightly rounded corner. What I've got is I've got an animation queued up that's gonna change the border radius of each of those boxes. Ready? Oh, look how much it crawls. So it's not always a good thing to isolate everything and put a translate Z hack on it, because you can end up creating a lot of extra work. If you end up having to paint each one of these things, these all need they need re-rasterizing, and then they all need copying over to the GPU. Ew. Should be what you feel. So this tool is amazing. When you want to figure out, is something getting repainted, what's getting repainted, switch on that tool, have a look at what goes red. If you see a big red flash across your whole screen, you've probably got a problem. Okay, so that's a good way to find that out. So painting, avoid it. You can't avoid it on the first time you page loads, but you want to try after that. You can promote elements to isolate them. If you have one element that is moving around and maybe does need repainting, promoting it is actually often a really good way to just make sure that nothing else has to be repainted unnecessarily. But bear in mind that it can also spawn other layers, like I showed with the next and previous buttons. You just want to be careful with it. Layers themselves do actually have a knock-on effect for memory, the management, and the transfer, as I've mentioned. So just be careful with that. Often people say, well, how many layers can I have? And there isn't a good answer to that, because it depends on the device that you're talking about and whatever else you're actually trying to do. So you just profile it and see if you can see how your frames per second is doing and respond to that, really. Paint storms, we were debating this term earlier, or what it really means. What it really comes down to is you wouldn't want to be caught in an actual storm. You don't want to be caught in a paint storm either. It's generally you're doing paint that you shouldn't be doing. You're either painting too much or you're painting too often, all those kind of things. It's just a nice name for saying it's not what you want to be doing. You're doing too much paint, so don't do that. Interestingly, because the GPU is exceptionally good at these things particularly, they often don't cause paints. If you isolate something, isolate an element, and then monkey around with its opacity and transforms, we won't be repainting. Like those boxes, they didn't repaint. It's happy days. We all smiled a happy smile. Image decodes and resizes. Those are done on demand. So when we're rasterizing, we hit one of those draw bitmap calls, we actually queue up the decodes and resizes. So it can make for very sporadic frame rates, let's call it, because we do it on demand. So when something comes into view that we need to rasterize, we go and get the image, we decode it, which could kill us. And for all intents and purposes, that's not a good thing. So bear in mind that handling images is expensive. You can't really avoid images on the web. But just bear in mind that handling them is expensive. So you want to see if you can mitigate it. And one of the best ways to do that is actually avoid resizing them when you can. And I say that frustratedly, because responsive web design is A, popular, and B, quite cool. But it does put a really heavy tax on the browser. So if you're going to do it, just know that there's a tax and be happy to pay the tax. There you go. Now, requesting an animation frame, if you've not come across it, when you are changing things on screen, please avoid these. They are not timed to the browser's refresh cycle. So they will just run whenever suits, and that could be at the worst possible time for the browser. What you want to do is use friendly green request animation frame. It's so helpful. Anybody use jQuery? Yeah? Anybody use jQuery Animate? Yeah, okay. It currently uses set interval. I would love that to change. In fact, I actually double checked that from the jQuery source. It does use set interval. There are patches that you can apply that then switch it back to request animation frame. Be a simple enough thing to do, and it might be worth it for your project if you are using jQuery Animate as it stands today. Scrolling performance is a big, big deal, actually, because most of the time people scroll on the web. Apparently it happens quite a lot. Scrolling then, it does cause paints, because as content becomes visible, we have to rasterize, we have to paint that stuff. So we want to make sure that when we do it, we keep things light. The easiest thing to do with scrolling is to avoid doing anything in scrolling. There's a really good one, actually, that you might want to look at, which is it doesn't take too much imagination. If you're scrolling through and you trigger a hover on an element as you're scrolling, then we have to repaint the thing that you hovered. Then you keep scrolling and you hover out, and we have to repaint the thing that you now hovered out, just because you were scrolling past it. Okay? Now, if your hover effects are really expensive, that's going to be awful. What you want to do is you want to basically switch off anything changing. So you basically add a class or something that basically switches off hover effects while you're scrolling. Wait a little bit of time and then switch them back on again. Happy days. There's a HTML5 Rocks article about that I wrote. Pretty good. I mean, the idea is good. It wasn't my idea. I just wrote it up. Anyway, debounce scroll handlers. What do you possibly mean, Paul? I mean this. If you add a scroll listener to your window in this case, don't do anything inside that scroll handler. Please, for the love of all that is decent, don't do it. What you do, store the value if you need to. Great, super. And then schedule a request animation frame to handle the scroll, the thing that happened. Because you could get 5, 10, 20 of these events, but really, you probably only want one. You want the last one, most likely, to know the current scroll position because you're doing a parallax site. What? Just because it's cool doesn't mean it's right. Just throw that out there, if anybody's listening. Okay, last thing I want to do, probably because we're running low on time, is just do a little bit of myth busting. JavaScript. You'll notice I haven't talked about it at all. You'd have maybe thought I would, right? Because when we're not talking about page load time, we're talking about JavaScript and how slow it is and horrible. But it's not, actually. Work is often triggered by your JavaScript. You maybe change a class with .class name or class list or something, whatever. It's often triggered by JavaScript, but the work that's actually running is often carried out in C++. Layout is not done in JavaScript. Layout is done in C++. It's done lower down. So bear that in mind. And slow JavaScript is, this kind of idea that, oh, JavaScript is slow, and that's why the mobile web is slow. No, it's not, actually, the reason most of the time. Because it's not JavaScript that's actually running. It's the other stuff that's inside the browser that's actually running. Unless you're making a game. There are classes of applications that do rely on JavaScript quite heavily. I do want to say that I'd like you to start treating JavaScript benchmarks with deep, unyielding cynicism. Because JavaScript probably isn't your bottleneck. Layout probably is your bottleneck. Paint is probably your bottleneck. So, if you start seeing, oh, it's really fast with JavaScript, yay. So, and then the other thing is the DOM is slow. You hear this one quite a lot. For fairly similar reasons to the last, actually. Interacting with the DOM is actually quite fast, as it happens. The problem is that changes to the DOM probably incur changes that are layout or recalc style, layout, paint, composite, misery. So, be careful. Now, going forth, aim for 60 frames a second. It is well and truly achievable. You control the browser's workload. You are, in fact, the ship's captain. I brought it in. I brought it back. Performance is a feature. It's not a unit test. It's not something you get to the end of the project. Am I fast? No. Ship anyway. Nobody will notice. Wait till they complain. That's what we'll do. No, do it. Think of it. Put it on the list. It might be 2, 3, 4, but make sure it's on the list. Ideally, put it number 1. I do. I love that. Profile, then fix. A lot of times you'll read things that are like, this is fast. Do this, and that's fine. Sometimes you need to do that, but you end up writing things that don't fix the problem you've got. You end up writing something that makes paint better, but you've got a layout problem. Profile, use DevTools. Paul will show you how. Profile your stuff, figure out where you're actually slow, then fix that thing. Sounds simple enough, because it is. Profile early, profile often. Smile, happy, smile. Do it. Thanks. Time for a break, innit? Yes.
Paul, thank you for speaking. Here's our San Francisco HTML5 speaker gift. Original painting.
Thank you.
And a little bit more. All right. All right, thanks everybody. We have a break. We need to be back here seated around 8 o'clock, not too much later, to keep on schedule. We have dessert out. We have more wine, beer, the sponsor tables. Check it out. Enjoy. Announcement by Florian.
Okay.
Testing, 1, 2, 3.
So, hi everyone. It's Vitamin T again, and just want to make an announcement about the GoPro camera. So, this drawing is separate from everything else. You have to give us a business card in order to be considered, like, we weren't part of the whole ticket thing, so it's not going to rely on the ticket that you received, it's a business card. So if you haven't dropped off a business card yet, please do. Ani and Ariel are walking around with containers, so you can drop it in if you want to be considered. The odds right now look like they're 100 to 1 for a GoPro camera. So if you want to get in the drawing, please drop off a card. All right, thanks.
Thank you. All right. So the next up, quick announcement about the Bounty Source project. You want to take it away? Great. Thanks, Warren.
Hello. My name is Warren. I'm one of the founders of Bounty Source. Bounty Source is a crowdfunding platform for open source software. So you can basically come to the site and you can place bounties using Google Wallet, PayPal, etc., on GitHub issues, Bugzilla issues, track issues, and so on. And so if you're a developer looking to earn some extra beer money or quit your job and work full-time on open source, Bounty Source is actually a great platform to do so. We work with GitHub, Track, Bugzilla, all those platforms. We also have fundraisers, kind of similar to how Kickstarter works, but exclusively for open source software. We've worked with some large companies like Adobe and Mozilla, and we're growing quickly, so definitely come check us out. We're We also just launched a new feature called Teams. So if you're part of a company and you want to give your developers a budget, or you're a developer and want to have a budget for yourself to go spend on bounties and bug fixes and so on, ask your managers or your coworkers to come check out Bounty Source. You can basically allocate $1,000 to a team, and members can come in, and when they get a bug, instead of fixing it themselves, they can go create a bounty on it. Anyways, thank you very much. If you want to come talk to us, we're all wearing green T-shirts that say Bounty Source. Thank you all for coming out tonight.
Thank you. All right. Okay, so our talk is now starting. So Jake Archibald, also here, all the way from the UK. We're really happy to have him here. He's a developer programs engineer in the Chrome developer relations team. And before working at Google, he worked at Lanyard and basically made that whole site work well offline, which is amazing. You may know him from his douchebag article.
I've got to shake that. I need to shake that. Hey, you're the douchebag guy. Thanks, everyone.
I can assure you he's not a douchebag. All right, so thank you, Jake.
Hey, excellent. Okay, people at the back, how's that? People at the back, can you hear me? Yeah? Is that good? Excellent. I'll try and keep this volume up. Wave if I let up. Okay. So, yeah, I'm going to try out something a little bit different, and it kind of depends on the Wi-Fi working. It's been a bit of a nightmare. It's probably a stupid idea, so let's find out. We're going to do like an interactive quiz. These slides are going to be interactive, so if you don't have a web-enabled device kind of in front of you now, get it in front of you. You know, a laptop or a phone, it will work on both, but make sure you've got that ready. It's a quiz, but it's really just an excuse to string together some bits of browser trivia related to performance stuff. So what you'll need to do is get on the Google Guest Wi-Fi. That's the SSID there. And then if you go to this lovely URL, which is my laptop here, so that's 192.168.156.69 port 3000, and there's a clue. Yes, it's a node server. Fair enough. Yeah, if you're watching the live stream, nah, that's not going to work. Sorry, just play the game using your mind or whatever. Just play with yourself. No, wait, no, it doesn't matter. Okay, move on. Once you go to this URL, you'll be asked to enter a username and password. Just make up any old password. It's going to be stored in plain text on my machine, so don't use your credit card number unless you wish to make a donation. All donations are gratefully received. The reason I'm asking for a password is if you want to switch devices halfway through, like you start running out of batteries or whatever, you can just enter the username and password again on another device and pick up from where you left off. Now, I hacked this thing together quite quickly. You could probably break it by trying to break it, so please don't do that. You know, I've at least made sure little Bobby tables can play, so if you're in the room, you're all right. Is everyone getting access to it? Is it kind of working? Wow, brilliant. I want to stress that this quiz is tough, and I've seen it catch out people who do this sort of stuff, this minor details of browsers for a living, and it catches them out. So if you're the kind of person who like flips tables over when you don't win, then maybe stay away from tables for a little bit, because this could get rough. Okay, I'm going to get this huge, horrible Helvetica off the screen. Oh, of course, what kind of quiz would be complete without a grand prize? The Chromebook Pixel is Google's latest laptop featuring an i5 1.8 GHz processor, 4 GB of RAM, and a touchscreen with a higher DPI than a MacBook Pro. Couldn't get hold of one of those, sorry, they wouldn't give me one. Never mind. But if you do win, then we will swag you. We will swag you good. You are quite dazzled by that. I thought you might not, so I thought I'd go all in and like, yeah, look at that stuff, a neon thing, a glass. Have you seen one of those before? And a cub, brilliant. Okay, the lens flares are sold separately. Sorry about that. Let's get started. We're going to start off really simple, like images in HTML, right? You've done that before. Fair enough. Okay. Here is a div. The div has a source, like an image might. Which browsers do you think are going to make a request for that? Now, on your phones and your laptops at the moment, it should have given you the options for this question. If it hasn't, just hit refresh, and you should get them. Now, when we're talking about these browsers, we're talking about the latest version of them, the latest stable release. You get 1 point for each one you get right, and you will lose a point for each one you get wrong. So if you say Firefox doesn't make a request, and it does, you will lose a point there. You can assume the HTML5 doc type, and there's nothing funky in the head like a base tag that might throw things off. There's no trickery going on. And what we're seeing here is a live readout of the opinion of the room. So the needle will swing one way when you think yes, it will swing the other way when you think no, although the direction is randomized for each question, so you cannot just vote along with the room. You will be probably getting it wrong if you do that. Right, OK, that's probably enough time. If you haven't answered yet, answer quickly, because I'm going to close the question in 3, 2, 1. And OK, so the needle's kind of going roughly in the middle, which means collectively you don't have a clue. Well done, everyone. You're kind of thinking yes in, well, most of the browsers, kind of more strongly in Internet Explorer. It's almost like you've been bitten by that browser in the past. The answer is, of course, no. Not in any of the browsers. Not that I'm going to do that. Well done, the people who got it right. 4 people by the sounds of things. Excellent, well done. But this is not as mad as it seems. So in XHTML2, you could do this. You could have any element, like such as a div, with a source. And the browser would replace that element with the content of that resource. And it was kind of a good idea, or it was the start of a good idea, because you could take rich semantic content and replace it with an image. It made the alt attribute completely redundant. Pretty cool, but XHTML2 had the backwards incompatibility issues, and it carried with it XML's draconian error handling. And once you invite XML into your home, it XMLs everything. It XMLs all over the carpet, up the walls. And in the same way that Smurfs stick the word Smurf in front of everything to make it a Smurf thing, XML sticks X at the start of everything. You don't want HTML, you want XHTML. You don't want frames, you want X frames. You don't want forms, you can have X forms. If you let XML take over your life, it will turn your boyfriend or girlfriend into an ex-boyfriend or girlfriend. And XML cool with that, because you don't need a partner, because you've got XML to look after you now. It seems fitting that in 2009, XHTML2 became an X specification, and we didn't care about it anymore. And no browsers ever implemented source on something like a div. But what about this? We've got an image element, it's got a source. Which browser is going to make a request? Now, notice that I have spelled image incorrectly in terms of HTML. Does the browser treat this like an unknown element, or does it do something special? I mean, we saw XML was too draconian, too strict for the web. But is HTML this lenient, or are the browsers more lenient than the spec in this case? So we're seeing you're kind of leaning towards one way. In pretty much all the browsers, you're changing your mind, going back into the middle. We're going to keep this rolling quickly, so just make a decision. I'm going to close the question in 3, 2, 1. And it's closed. So you're kind of thinking pretty much yes in all the browsers, and you would be absolutely correct. In all of them, it will make a request for the image. And note in these situations, it doesn't have to show the image. We're just talking about making a request. But in this case, all of the browsers will actually show the image as well. You see, back in the past, I don't know if you remember the past, but one browser decided that IMG was too difficult for developers to remember, and that image should work as well. And we've been stuck with that ever since. Now, which browser vendor do you think we have to blame for this? Oh, yes, of course, it is Mosaic. Back in 1993, the people who invented the image tag, they did this. And a study in 2005 showed that like 0.2% of pages were using this incorrectly spelled image, so all the browsers have to support it for pretty much forevermore. The WhatWG recognized this and added it to the spec. This is the parsing spec, and you can see there, start tag, if it's image, change the token name to IMG and reprocess it, don't ask. Right. But recently, IMAGE was using a clever hack. Alexi 10 came up with this. So you would use this on your page instead of an image. This block of sort of SVG with an image inside it. And what it'll do is it'll show an SVG in browsers that support SVG, and it will do a PNG in other browsers. So a modern browser will parse it like this. OK, that's an SVG element. OK, it's going to be 100 by 100. That's fine. Oh, and this is an SVG image, because in SVG, image elements are spelled fully, IMAGE. Oh, it's got a width and a height. That's great. And I'm going to load img.svg, because this is how you define the source for an image in SVG, because it's part of XML. And why have a link when you can have an X link? And then it sees this and it goes, that means absolutely nothing to SVG images, so I'm going to ignore it. Whereas an older browser, maybe as the Android 2, IE8, they'll parse it like this. I'm going to ignore that. Oh, look, the developer spelled image wrong. OK, I'm going to use that. It's 100 by 100. Whoa! Developer got high. I'm going to ignore that, and I'm going to load img.png. It's great. So you've got this kind of doesn't require JavaScript, and you're switching between the two image formats. And we got kind of excited about it, and we started tweeting about it. The mistake we made is we didn't test it. So a few of us started testing it, and we found something interesting. All of these browsers support SVG. Which ones download both images? They shouldn't, and I'll give you a clue. It doesn't go one way or the other for all browsers. Some of the browsers are doing it differently, so you're going to have to pick the browser or browsers that you think get this wrong, because not all of them get it wrong. I'm going to close the question. Oh, oh dear. Oh, no, OK. There's some IE fans in the room. Closing the question in 3, 2, 1. OK, so you're edging towards Internet Explorer being the bad guy here, and in this case, you are correct. As a kind of group, you're doing quite well. You should all form a company or something. It's great. So all the browsers here, all the latest versions, they have 2 parsers inside. A relatively new thing for browsers to have, but these ones, they all have it. One parser runs ahead as quickly as it can and picks up things that it should download, like images, scripts, all of that sort of stuff. The other parser does the heavy lifting, like building the DOM tree and parsing scripts and all that stuff. This has a surprisingly large benefit. Ilya is posting about this study that was done through 2,000 sites, and it had a 20% speed improvement. That's pretty incredible. That's time to get to DOM content loaded. In order to be quick, this other pre-parser, this first one, is a little bit stupid. In Internet Explorer, it's that little bit too stupid. And it kind of gets overexcited, and it's like, I'm going to show a PNG. I'm going to show a PNG. Yep, here I go. I'm going to show the PNG. Here it goes. Nah, actually, no, it's an SVG. Never mind. Fair enough. It kind of sees the image, but it misses the SVG context, so it picks up the wrong source. And then the main parser comes along and goes, what are you doing? No, this is an SVG thing, and downloads the correct thing. The moral here is don't just, if there's some kind of performance advice going on, don't just blindly trust it. In Chrome, we say, use tools, not rules, and it rhymes, so it must be true, right? But but also be on the lookout for existing tests. If someone's done the legwork for you, and you can just sort of run that test yourself. One of my favorite stories in science involves this guy, August Weismann. He wanted to disprove that evolution was learned. Like if you had some kind of life experience, that would be passed to your children. He wanted to disprove that was a thing, because it wasn't the Darwin evolution. So he took some mice, and he cut their tails off, and he bred them together. And then the next generation, he cut their tails off and bred them together as well. And the theory was, well, if evolution is learned, we're going to start getting mice born without tails. And he was quite a way into this research until someone went, you do realize, August, that the Jewish people have been carrying out this test a lot longer than you have. And I was like, oh, yeah. Fair enough, yeah, OK, job done. So yeah, don't reinvent the wheel unless you want to learn a lot about wheels. And that can be cool sometime. OK, what about this? I've got an image. It's inside a div that's displaying none. This image is not going to be displayed, but which browsers are going to request the URL and download the image regardless? So yeah, I do it quickly. We're going to go for, we're still thinking IE is going to do something different. People are thinking Firefox is going to do something different. I'm going to close the question in 3, 2, 1. There we go. The countdown's going to get old, but I'm going to do it for every question anyway. OK, so we're sort of saying yes in IE, maybe no in Safari, no in Chrome, and maybe in Firefox. The answer is yes in all of them. They are all going to download the image in this case. And this behavior is part of the specification as well. In the beginning, there is nothing, right? And then the browser gets sprayed with HTML text. And then from that, it's going to construct this tree of elements that, as Paul was explaining earlier, is the DOM. When one of these things is constructed, the constructor steps for that element are run. And if we look at the spec for image, it's quite complicated for what you'd think would be a very simple thing. But this is the image stuff. It all runs synchronously. Step 14, fetch the image. No mention of CSS, no mention of anything like that. And that's good in some ways, because it means the browser can start the image downloading before the CSS is there. The pre-parser can deal with it. Downside is, well, we couldn't do polyfills for things like responsive images, because by the time JavaScript gets there to do something clever, the image has already started downloading, and you're just going to trigger a second request by changing the source. This won't be a problem in the future. The resources priority spec has this postpone attribute, which means the image won't download if it's display none. And it allows the browser to avoid downloading it even if it's just out of view on the page as well. So you don't have to rely on these heavy scroll events for image lazy loading. OK, what if we're using CSS? Does visibility matter then? What about this? Once again, that image is not going to be displayed because it's inside an element that is display none. So we saw here that the image would download in this case. But what about in CSS? Is it going to do something different? Does visibility matter here? Which some of the browsers are going to do something different? I'm going to close the question in 3, 2, going right to the middle. Collectively, once again, no clue. Don't worry about it, guys. It's quite difficult. What's the answer? None of the browsers will make a request here. And that's kind of cool, right? We want to be able to rely on that kind of behavior. Slightly different one. What about now? Same thing again. The image is not going to be rendered because it's on a display non-element. But it's not inside a display non-element. It is on a display non-element. So we saw it was the browsers weren't downloading before. What about now? Did the browsers do something different? Did they all download it? Did they all not download it? I mean, they don't need it. It's not going to be rendered. I'm going to close the question in 3, 2, 1, done. All right, we're saying no in pretty much every browser. Most browsers will download it in this case. Only Firefox won't. So what's going on here? Well, once you've got some DOM elements on the page, as Paul was explaining before, they're going to get their styles calculated, where the browser goes to see which, of your cascaded styles, of your font tags if you're from the 90s, which styles apply to each element individually. But not everything gets its style calculated. So we've got these two elements at the bottom, no style calculation. And the reason is this div at the top here turned out to be display none. And the browser shortcuts, because it knows the styles of these elements have no impact on the rendering of the page. So it doesn't bother. It takes a shortcut. So if these have background images, the browser never finds out about it. If the display none element has a background image, the browser does find out about it, and that's why we see most browsers downloading it at that point. Firefox is a little bit smarter here. But if you use something like visibility hidden or opacity 0, Firefox will be downloading as well. Who's getting it right according to the specification? Everyone is. It's great. The specification says absolutely nothing about this. There's this tiny note that says the browser may optimize. It may avoid downloading images that are out of view, even if it's like there's another element over the top. The browser may avoid downloading at this point. No browsers are that smart yet. This kind of freedom in the specifications is great because it means the browser can do what's right given the situation and the kind of device and the network connectivity, et cetera, et cetera. But it's also kind of scary because this is where you're going to get the browsers doing different things, as we saw here. But I kind of like that. I think that's the diversity that makes the web great. It's not one company driving forward with its own interests. It's lots of companies driving forward in different directions. And we get this sort of car crash, but a car crash with a happy ending. And that's the web that we have today. So if you want to avoid downloading backgrounds in CSS, hiding the element isn't enough. You need to put it inside something that is hidden, so the browser won't find, won't even look at that element. But when you do that, realize you are relying on just what the browsers do. It is not specs behavior. The only surefire way is don't let the browser find out about the background image. Take the class off until you need it. Or don't put the element in the DOM until you need it. All right, things have been quite easy so far. Let's get JavaScript involved. What do you think? Creating an image element, once again, I've spelled image wrong. I'm applying a source to it. It is not in the document, so it's not going to be displayed yet. And it's spelled wrong. We saw the browsers correcting for that before, but that was in HTML. What about in the DOM? Is it going to be different? I'm going to close the question in 3, 2, 1. Right, done. OK, so we're kind of edging towards yes in most browsers. It is yes in most browsers, except Firefox. Firefox does something different here. And there are two parts to this explanation. We saw before that the DOM builds up and these creation steps for elements are run. But even if you create the element and it's not part of a document, that's still going to run those creation steps. And we saw before, step 14, fetch the image. We can use this to our advantage, because you can make a GET request to any URL by making an image element and assigning a source. And you could use the image element constructor. It's a tiny bit of code. You can make a request anywhere. This is kind of how Google Analytics communicates back to the server. Oh yeah, but Firefox didn't make a request. So what's going on there? It's because we spelled image wrong. And most browsers, Chrome, Safari, IE, will give us an HTML image element when we do that. Firefox will give us an HTML element. It's not an image. You add it to the page, it will not show an image. And you know what? It's the only one getting it right. We saw before that the specification says if you encounter a start tag, you can correct it. But this is the parsing spec. We bypass the parsing spec by creating the element in JavaScript. So yeah, actually, technically, it should have returned an HTML unknown element. But you know, it's getting it closer to right than the other browsers. I think I kind of preferred it when the web, with all the browsers, like there was one bad guy and all the other browsers seemed perfect. You know, it was like an orchestra, and Internet Explorer 8 was just this screaming child hitting two cymbals together. But then we finally got rid of the screaming child of the cymbal, and then we started conducting again, and we went, oh, actually, everyone's out of tune. We just didn't notice because of the screaming cymbal child. Oh, fair enough. All right, let's get CSS involved again. What about this? So, as before, creating a div, but I'm going to give it a background image. So I'm not creating an image, creating a div, giving it a background image. We saw here that images were downloaded at this point. Is it different with CSS? Do different browsers do different stuff? So we're kind of edging towards the don't know. Oh, wow, it sort of swung the other way. Closing the question in 3, 2, 1. All right, so we're edging towards yes in everything. Wrong uns, the lot of you. No browser will download here. And this is kind of the same as the display none case. It's not in the document, so the browser's not going to go looking for the styles, because it doesn't need to know the style information, because it knows it's not going to render. All right, going to be cruel. Same thing, but I'm going to add it to the DOM, and then I'm going to take it away. In the same block of JavaScript, will the browser see that element in the document long enough to actually trigger the download? What do you think? I'm going to close the question in 3, 2, 1. We're edging towards yes in everything. Wrong again. None of the browsers. None of them. The browser doesn't think about styles or layout until as late as possible, which normally means when it needs to render something. And this isn't going to change any pixels, because JavaScript's going to be blocking the chance to do some of that painting stuff. What about this? I'm adding it to the document. I'm going to ask for its text content. It's an empty element. Text content is going to be empty as well. And then I'm going to remove it again. Does that trigger different behavior in the browser? Element's completely empty, so, But is that going to trigger the browser to go, oh, yeah, I'm actually going to get that background image? I'm going to close the question in 3, 2, 1. What have you said? You don't know. Fair enough. Yes, it's tricky. No. None of the browsers at this point. I am going somewhere with this, I promise you. Getting the text content of an element is pretty easy. It's just going to go and pick up the text nodes. Doesn't need to look at the style or anything. What about this one? Inner HTML. Same as before, but instead of text content, going to ask for the old inner HTML. Oh, wow, IE is doing something different to everyone else. Interesting. I'm going to close the question in 3, 2, 1. All right, so you've said yes in IE and no in everything else. Bloody hell, you're right. Well done. Yeah, IE makes a request. And the reason for that is because, I don't know. Some things in the world cannot be explained, like why it takes 3 attempts to plug in a USB cable, even though there's only 2 possibilities. These things just cannot be explained. Moving on. Similar again, instead of inner HTML, it's inner text. What do the browsers do here? Do they do something different? We saw IE is quite request happy with inner HTML. Does it do something different with inner text? Does it trigger requests in any of the other browsers? I promise you, I am going somewhere with this. Closing the question in 3, 2, 1. There's quite a strong opinion of no across all the browsers. Sorry, guys. Yes, in everything except Firefox. And this actually makes sense. Let's make a div. We make a div. We give it a background image. I'm going to give it inner HTML, where it's got hello world, and the div is a div around the world, or whatever. Text content is hello world, as you might expect. The inner text has a line break in it. Or this is how it is in IE, Chrome, and Safari. Because inner text is more like what you would get if you copy and pasted the element, the text of the element. And because div is a block level element, or it certainly is in this example, it gets a new line. So if we run this, the browser goes, yeah, text content, easy enough. Inner text, oh, inner text is style dependent, so I'm going to have a look at the styles of the element. And oh, it's got a background image. That's interesting, I'll download that. And that's why we see most browsers doing it. Firefox doesn't download at this point because it doesn't support inner text. It's the only browser that doesn't, so it just returns undefined at that point. But if you used any of these, apart from inner text, like anything that's going to get some style data from the page, Firefox would have started the download as well. So Paul was talking about this earlier. You can start doing layout thrashing if you start doing these reads and writes. So you'll trigger extra layouts, etc. The browser is quite clever about this stuff. It will batch changes together. I mean, if you do this, like display non-block, etc., loads of width, this is actually a really light piece of code. It's not tricky for the browser to understand because it's going to ignore. All right. I hope that's not my cue to get off because that's very passive aggressive. Anyway, so it'll only take the last change that you make. Oh, that's nice. This is great, but it can lead to unexpected results. Let's have a look at a practical example. Paul and we want to go over there. You can tell because we're pointing. Let's do it with code. I'm going to start at left 0. I'm going to transition left 1 second, go to 100%. We run that code, and it works. Yay, we solved the world's problems with code. Now, we're very happy at this point, but let's run the code again. Nothing happened. And this is because the browser is going to ignore this first right of left. It's just going to batch them together. It's only going to listen to our last right here. And it's 100%. We're at 100% already, so nothing happens. We can fix this by forcing a synchronous layout here, because that forces the browser to go and look at all the styles of all the elements on the page, and it realizes, oh, yeah, we are supposed to be at left 0. So when we make the next changes, it will start from 0. If we can run this code as many times as we want, and it works. You might have encountered this kind of behavior and tried to use set timeout or something to get around it. No, you can just force a layout like this. Right, OK, last question. Let's get through this quickly, because I'm going to be chucked off the stage in a few seconds. Imagine a page full of lorem ipsum. It looks like this, 595 pixels across. Media query, min width 600. Min width, so we wouldn't really be expecting it to display. Which browsers are going to download that GIF anyway? Are the browsers going to do something different? And you say, would we expect it to even display that GIF? Who knows? Last question, so make it a good one. Closing it in 3, 2, 1. Straight down the middle. I feel like I've broken you as an audience. I'm very sorry. What happens here? IE and Firefox will download, and they will actually display the background as well. And this is quite sneaky. My measurement did not include the scroll bar. With the scroll bar, it brings it over 600 pixels. Now, they don't call me Cunning Jake. They don't actually call me Cunning Jake. Yeah, fair enough. This seems insane to me, to include the scroll bar width. What if the user has a 200-pixel scroll bar? Why should I care about that? But including the scroll bar is mandated by the specification. It's interesting. And Chrome and Safari are breaking the spec here. It's fixed in the Chrome nightlies. It's not fixed in the WebKit nightlies. Why is the scroll bar included? Well, imagine this bit of code. I'm forcing no scroll bar, and then when the width gets to 600, I'm going to introduce a scroll bar. 500 pixels, that's fine. We get to 601. We need to put a scroll bar in. Oh, now we're less than 600 pixels. We'll take it away. And so on, and so on, and so on. In reality, it doesn't get stuck in a loop, but here we can see what Safari does. I've got a background picture and a scroll bar coming in at a particular width, and we'll see as I'm only making it bigger. I'm not moving both ways, and we can see that the background image flickers on and off, and then once we get beyond the width of the scroll bar, it stabilizes, and that's it. Let's have a look at the rankings. Don't worry if you haven't scored, great. It won't actually show your name on the screen. It's only going to show the top 10, so don't worry too much. Who have we got? Pretty fly for a Wi-Fi. Very good. Who's that? Excellent. Right. I will swag you good and proper. Oh, God, you've done really, really well. OK, that's my time up. Thank you very much, guys. Cheers. Bye. Oh, thank you very much. Cheers. Oh, thank you. Cheers now. Right, I'm going to run away.
You know all the swagger, the swag?
Yes, I will catch up with you in a bit, and we'll do the swag thing.
Thank you.
Cool.
That's
right.
pretty good. Yeah. Also hiring. All right. OK, well, thank you, Jake. We're just switching laptops. Just a quick idea on the timeline. We have another 25-minute talk. And then we have a very short break, maybe 10 minutes, just to reset the the video and so on. And then we'll have a Q&A discussion until 9:30, at which point we'll start with raffling off all the goodies. All right, so next up we have Paul Irish, who is also a repeat speaker here at SFHTML5. Happy to have you back, Paul. And Paul's developer advocate in the Chrome developer relations team, focusing mostly on developer tools, and I think we'll see a lot more about that next. All right. Okay, we're doing a little so. Oh yeah, do you have the one? Aha. We're trying to get these monitors to work. They all worked in the pre-test, and they stopped working. So, again, a couple of events that are coming up. Chrome Developer Summit, November 20 and 21st. It'll be at in Mountain View at the Quad, the Google office there. We'll be live streaming that event as well. There are about 300 people that can fit in the building there. Registration will open in October. We'll post some things about that. HTML5 DevConf happening the week of October 20. Training sessions, followed by a 2-day conference, and then two days of training on top of that. Very, very reasonably priced, so definitely check that out. And well, you're going to have the mic on there. All right. Are those screens working or no? Okay.
That's cool. Yeah. That seems almost workable. Yeah. Hey. All right. This is nice. Oh yeah. Hey girl. Still loading. It's kind of aggravating to look at, isn't it? It's just like, come on. Yeah, okay, so let's start. I'm going to talk a little bit about the tools that are available to identify and improve some of the things that we actually saw tonight. And so to start off, I want to kind of separate some of the performance ideas into 2 separate buckets. If this works for you guys, I don't know. It seems kind of okay. Like the user experience of performance is mostly separated into 2 things. Like, give me the damn thing that I wanted, and now that I have it, I want to interact with it really nicely. So in give me the damn thing I wanted, it's page load, often abbreviated as PLT, page load time. In here, we're talking about things like the network waterfall, getting image assets that are appropriately sized, non-blocking delivery of all of our assets, getting the CSS that we need to render the top of the page quickly and not much else, and also fonts, can we see the text quickly? When we're talking about runtime performance, we're talking about, like, I want to interact with the page, I want to click a button and see that response very quickly. Any sort of transitions, animations. When I'm scrolling, does it stick to my finger? Like, I am scrolling with my finger on the device, and it should just be moving immediately with things. What we heard about with memory leaks and garbage collection, and also JavaScript-based animation, like with request animation frame. But to show a little bit more about this stuff, I kind of want to take an example. So we're going to start off with a demo. This is a site for a festival in Canada, and it's the Canadian National Exhibition. So we're actually just going to go over to the site now, the live site, and we're going to play around. I'm actually going to do it here in Chrome Canary. Okay, cool. So how does this look? Oh, it's too wide. Okay. Yeah, seems good. All right. So Canadian National Exhibition. My friend Mike Taylor, who works for Firefox, found this site, and he said, I defy you to find a site that is jankier in its scroll. And I was like, I know of a site, actually. So like this one, what is it? Inception Explained, is it? Is this it? Yeah. It's really bad. It is. So Paul mentioned parallax sites before. Parallax sites can get into trouble really fast. And this site is so cool, but the frame rate on this is just so poor. It's rough. But let me go back to what I was talking about. So Canadian National Exhibition. So here we are And we got some things happening. We got this layer on the background, full bleed on the back, this header that kind of moves, it scrolls up as I go down. But let's actually look in the tools to see what we're talking about. All right, so first thing, I'm just going to turn off this debug mode I had on earlier. And always first thing, go to timeline. Start recording. I use Command E, and we just kind of scroll up and down. OK. So we're seeing a lot of activity already, all right? A lot of stuff. We're seeing mostly purple, right? I'm scrolling in on this area to just kind of get a better zoom. And it looks like recalc style is consuming a lot of each of these frames. So OK, recalc style. Some things could be happening. I'm not really sure what. So we hover on the item, and we can see the JavaScript call stack that's associated with this. So the last thing that happened was here inside remove class inside jQuery. OK, so I'm going to click that just to find out what exactly it was. We're minified here. OK, we'll pretty print down at the bottom. It looks good. Now I'm going to come back and just repeat that click again. OK, cool. So now we just repeat the click, and it brings me to the exact place. I really like it when the cursor does its pretty thing. So I'm going to, yeah. So it brings me right to the class name assignment. So this is setting the class name on an element. And that is what triggered the recalc style. OK, that's good to know. Now let's find out why that happened. We look down into the user code. And so here we go inside cne.js. Let me try clicking that once again. Line 33. Remember how Paul might have mentioned do as little as you can inside your scroll handlers. So inside their scroll handler, they get the height of the window, the scroll top, they do a little bit of math, and then they toggle some classes on the HTML element in every single scroll. Toggle, 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 toggle. Not great, certainly not great. But we can make this better. So so the best way to do this is, you can see it's a conditional toggle class, right? You're using the second argument inside jQuery's toggle class. They conditionally change it depending on that math working out. So that's OK. So ideally, you set this in an if block, and you only touch the DOM if you satisfy that requirement. That makes a bit more sense. We can actually cheat things a little bit. So I'm just going to edit the JavaScript right here. One sec. This is OK. All right, I'm going to edit the JavaScript right here. So I'm just going to backspace. Oh, come on. All right, cool. And we're just going to get the DOM element itself. And then we're going to use class list from HTML5. And it turns out class list toggle actually has the exact same method signature as jQuery's toggle class. And now I'm just going to hit Command S. And Chrome is just going to update that function on the fly, which is pretty cool. So then we're going to go back to timeline. And I'll start recording again and repeat my action. Yeah, nice. Pretty sweet. So here we are. We do not have massive recalc style anymore. But we do have some green paint going on. Now, on this device, I am still hitting mostly 60 FPS. So that's kind of OK. But on mobile devices, I certainly would not be. I want to see if I can do anything about this paint first. So first things first, I'm going to come over into the settings and turn on Show Paint Rectangles. And usually when I do this, I like to turn on Show Composited Layer Borders at the same time. Kind of go hand in hand. So bring the DevTools down a little bit. And now I'm just going to scroll up and down. So my paint rects are in red, and we're seeing things. A lot going on, but I can definitely see up top this section, the header is just in red nonstop. Now the reason why is because the header is position fixed, and the content is moving beneath it. But that is that's not going to work. So it's basically repainting this, even though it really shouldn't. It knows what that looks like, right? So the trick here is what? What's the fix for this fixed position element? Ooh, yeah, translate Z. There it is. I'm excited to type it, and then I also like dread it. Yeah. It's like a combination of things, really. Okay. WebKit transform, translate Z. Oh, my friend. Some people do like the 3D version, but then you have to do 0, 0, this is my favorite. All right, so I got that in. I promoted the layer, and in fact, there is now this little gold border around the top. And let's see if I can, if I just toggle this, you can see that gold border coming on and off because that is now a layer. All right, so we're going to put it back on. And if I scroll up here, oh, cool, yeah, we do not paint that. But then we get about here, and it moves. And we see that paint. And actually, so let's fix this. So the movement is here, top. We just move the top. Now, what's probably a better way of moving this top other than just changing position absolute? If we want to move an element. Translate, yeah, sounds good. Let's do a transform translate. All right, so WebKit and WebKit and Blink still have prefixed transform, so we will do that. Hop over here and do a translate Y, and that seems to work. And since I have a CSS transition down here, I should probably update that. Okay. Now that's a bit nicer. I still do see red. Let's see if, yes. Is that right? You know. And it feels, I don't know if it feels smoother to you, but it feels smoother to me. It feels good. All right. So that's pretty good. And let's take a look over in the timeline. All right, cool. So in general, in the middle, we got like nothing going on. We got a little bit of paint up when I'm going between the top or when a new image is coming in. That's pretty good. So that's a little bit of things that we can do inside the DevTools. I actually made a video showing kind of taking this all the way. The background has a fixed position, and we can actually move that to the body element and get some wins there. But I'm going to come back to my slides first. Slides first. Oh, yeah. All right, so I want to walk through some of those operations that we were seeing. Recalc style. So what's happening inside recalc style is it is getting all the style rules that affect the page. This is anything inside a style sheet, an inline style, the user agent style sheet. It's getting all those style rules. It's bringing them into an object model. And then it takes all those selectors that you got hanging around and matches those against what's in the DOM. And it says, oh, yeah, it's that one right there. Yes, the selector matching. Now, as Paul said, it happens really fast. Usually in recalc style, the selector matching takes up about 10% of the general purple bar. Not very much. Don't worry about it. Now that it has that and maps against the DOM, it calculates the computed style for every single DOM element. So you know in JavaScript when you ask for get computed style, it's doing that. But for every CSS property, for every element, it figures out how things should look. Makes sense. OK, moving on to layout. Layout is the geometry of the page. And I want to show kind of one way to look at layout. So I'm going to open up this little demo right here. And come on. JSBin server is in the UK, isn't it? Yep. Yeah. It's like looking at a loaded spinner. All right, cool. So I'm going to click these buttons like that. Now, what I'm going to do is I'm going to hit switch layout, and we're going to start this animation. Now, if I open up timeline and record, you can see that as that animation is happening, we're getting a lot of layout costs. And that makes sense, because layout is reevaluating the geometry of the page. And this sort of animation here has to figure out this new text flow. And when the text flows, then we get a new height for where person 2 starts and person 3 starts. And it's a lot of work to figure out that new geometry. And it happens every single frame of that animation. It's a bit expensive. Now, the next thing after layout is determined is paint. We heard a lot about this from Paul. Paint hurts a lot on low-end devices. Old Android phones with not a lot of hardware have a tough time updating anything when it requires paint on every frame. Debugging this with continuous paint mode is probably one of the best ways to do it. So I'm going to show that real quickly. I said real quickly, and then I loaded up a JSBin URL. Come on, England. Come to me, the bits. All right. Handy trick. DevTools at the bottom, you might like it on the right. You can just take the bar here and drag it up to the... You can also click the button. Great. I have a lot of DevTools extensions, and I'm just going to make excuses. OK. You might have noticed inside of Chrome Canary that I have, wow. Let's go back. So we're here, we're looking at this page. We have lovely boxes all over the place. That's real good. But we're going to turn on continuous paint mode. Now, continuous paint mode basically says to Chrome, hey, I know you know what it looks like, but I just want you to tell me what it looks like again and again and again and again and again. So it's just going to repaint everything that needs to get painted. So if I look at timeline, it is just doing the same work over and over again. But what this allows us to do is make some changes and see how it affects that graph up there. So right now, we're looking at, what is this, 8 milliseconds or so per paint of the entire page. Now we can try some different things. So maybe I'm going to come over here and toggle the box shadows. So I turn on box shadows, and you can see pretty quickly, sorry about that, paint time dives really, really high. So the box shadow is adding quite a bit to how long it takes to paint the page. I also know that there's a border radius on these boxes. I can try turning that off, see if that makes any difference. It does make a slight difference, yeah. But this gives you an option to kind of figure out things. Now, a handy trick when you're using continuous painting mode is the H key hides DOM elements. So you can kind of walk through your DOM, hide things, and see what the effect is. So maybe you'll hide the header, kind of get that out of the way, and kind of bisect the DOM, figuring out where your costs are. This H works all the time. It's pretty handy. All right, so that's continuous painting mode real quick. I got a question recently, which is, there's all these operations inside the DevTools timeline. What is the order that I should see them in? And then what we're looking at right here is basically it. So a lot of times, you start off with some JavaScript. It touches the DOM. It changes something. Then the browser does have to recalculate the style, has to lay out the page, has to paint it, and probably composite some layers. Ideally, kind of, this is the flow, and there's only one operation per, basically, paint. Paint is the user got to see something. When we were talking about layout thrashing before, layout thrashing is oftentimes we're doing a bunch of recalc style and then layout, and then recalc style and layout, recalc style and layout. And the user doesn't see anything. There are no paints. So ideally, you have only one layout per paint. So here's a little cheat sheet for kind of taking action from what the timeline is telling you. If the timeline is telling you, oh my god, lots of yellow, there's so much time being spent inside JavaScript. I should point out that that Canadian Expo site, remember when I profiled it before? Was there any yellow at all in it? No. There was no JavaScript at all slowing down that site. It was all inside the rendering side. But if you're in a case where you are in a lot of JavaScript, you can use the flame chart. I'm going to show this really quickly. Who has seen or used the flame chart? It's good. It's a powerful thing. So this is MathJax. It's a really good polyfill for MathML. But I want to check out kind of how fast it can render these things. So I'm going to turn off these, come down here. And so it's actually just, it's rendering this stuff out. And I can choose to render it in SVG or HTML CSS. Come over to Profiles. And I'm going to collect a JavaScript CPU profile and record. Change this. Ooh. All right, cool. Now, normally, when you come into the JavaScript profile, you see something like this. Just go down to the bottom right there and select Flame Chart. What it's going to give you is a view like this. And so this is a time-based view of JavaScript execution. And it progresses from left to right over time, just like you expect on the timeline. And in fact, if you want, you can record on the timeline and on the JavaScript profiler at the same time. But you see some spikes. You want to go investigate what's actually happening. And so I'll take a look at the SVG one first. So we can see there's actually a good amount of latency. There's a good gaps between all these flames. And if you look on timeline, there's actually a bunch of network activity that's happening between these things. So they're making network requests as they're trying to pull together things, and it's a bit inefficient. Over in this version, they don't have that problem. But we can identify kind of where all the function costs are coming from. Now, height is just call stack. So height is really not important. What's important is width, because width is time. But we're able to see here kind of what are the functions that are taking up time. And we also get to understand kind of the execution code paths here, and what calls what, and how do we go from start to finish in this operation. All right. So that's if we're spending a lot of time in script. If we're spending a lot of time in layout, dig into the JavaScript that's triggering it. In the DevTools timeline, like I showed before, you'll see a call stack. Find out what you're doing in JavaScript that is forcing the browser to do a layout. With paints, find what is actually being repainted. Turn on those paint recs, turn on the layer borders, and see what's happening. You might have to promote a layer using translate Z to get out of a paint storm. This often happens with fixed position elements, but you kind of take another look at what Paul showed you. You can bisect what are actually expensive things happening using continuous paint mode. And if none of these things answer your questions, it's time to dig into about tracing, which is a really extensive tool, and I'm not going to touch it right now. But to tackle kind of like all these operations and how they actually map to your CSS, we should probably take a look at that. So if we take this little block of CSS, the selector up there, that does have to get matched up to a DOM element. So the selector will be caught up in recalc style. The height affects kind of the geometry of the box. So that is mostly captured inside the cost of layout. And a text shadow does not affect any geometry of the page whatsoever. It is just a visual effect, right? So it will have no effect whatsoever inside layout and paint. Now this is helpful to know because if you turn on continuous painting mode, it's only going to give you numbers that reflect things that have an effect on paint. So you change the height of a box inside continuous paint mode, not much really. You're not going to get a good result. But another way to look at this is that different CSS properties kind of affect these different things. So like Paul mentioned before, transform and opacity are really fast because the GPU can handle it 100%. So this happens here. They do not need to, if you're touching transform and opacity, you do not need to lay these out. You do not need to paint them. A few happen at paint. So this is box shadow, border radius. These are visual effects. Like I said, they don't affect any geometry. Outline is also here, because outline is similar to border, but outline, you can change like an outline from 1 pixel to 100 pixels, and everything stays the same place. But a lot of CSS properties do affect the layout. Of course, anything that affects the positioning of the boxes, width, margin, border, absolute positioning, relative positioning, these things affect layout. And actually, so I took a look at all the CSS properties. So Chrome actually just recently, yesterday, I think, released some numbers around the popularity of all CSS properties on the web. And this is them. So width is the most popular CSS property. Who would have expected that? But it's interesting to kind of look at these and identify kind of what sequence of operations they force. And so most actually do affect kind of the geometry of the page. But of course, opacity, like I mentioned, does not. Another cool way to look at this is animatable. Leah Varu made this tool. And hopefully I can show this really quickly. So this is just using keyframe animations just to change a single CSS property on a bunch of different things. But it's pretty cool to bring this up and try it out to see what it actually looks like inside timeline. So like I said, we'll take a look at, let's see, font size. Font size. There we go. So as we animate font size does cause layout, and we see it right here. Box shadow, like I mentioned, does not have any effect on layout. And, oh, did I lie? Ooh, tough, Paul. Let me try one more. There we go. That's pretty good. So we're doing a transform animation. It's just staying kind of on the GPU. We're not going back to layout. So this is extremely efficient when it comes to animations. So in transitions, there's a lot of things. There's 4 things that a browser can do really, really fast and jank-free. It can scale, can move, can rotate, and fade. These translate in CSS to these guys. I should point out, you might need the null transform hack. Maybe. But if you're doing any animations, any visual effects, you want to be doing them with these operations. These can be fast. It can be fast on low-end hardware. It can be fast on high-end hardware. Every other operation is going to incur layout or maybe a good amount of paint. So it's going to be slower. Now, when it comes to measuring, we want to know that these measurements, these performance enhancements that we're doing are good for people. If we take a look at Twitter, the load event, window.load, fires about midway through the network waterfall. And the end of activity is quite a bit later. So looking at window.load for knowing that the page is kind of done is not going to work out. So we need better ways to identify how successful are we. So this is an approach developed by a guy named Pat Meenan who runs web page test. So up at the top, we have the film strip view of loading a page that's been optimized 2 different ways. And so you can see that the third way was optimized, is delivering content to the user faster than the other ones. Down here is a plot of the percentage of the visual progress, plotting these out. So you can see here, we're already showing things to the user, and so that's why gold is jumping up. Now, if we want to take this and turn it into a metric, we can take the area above that line and just kind of absorb it into a figure. So this is called the speed index. It's basically the area above the curve that accounts for what the visual progress being shown to the user. So this is a nice kind of quantitative measurement for getting a successful picture in front of the user. Now, in the real world, we want to be able to identify things like how, as we're developing a project over time, are we regressing performance? Are we improving it? Adobe Topcode is a CSS library that has a really nice framework set up for benchmarking. So they're using a project called Telemetry that Chrome works on. And so this is actually a view of their button element. And on the horizontal axis, we just have commits. And we can actually see for the mean frame rate, the mean frame rate, the load time, and the layout, how things are progressing. And so you can actually see this is a pretty big regression in load time of this test case. And then things actually did slow down later here as well. But we're able to kind of track this over time, which is really powerful. Another developer took a look at this and applied this to Bootstrap over the history of the project from 1.0 to 3.0. And so this is just a quick view of the dropdowns component inside Bootstrap. And we're looking at the first paint metric. First paint is a tricky one, and it's hard to find good metrics. But I think speed index is one of the best ones. Inside Google Analytics, there's a few tools for these. If you're looking at network activity, you can identify page load time, domain lookup, page download time. All these are the exact same as window.performance.timing. But since all major browsers support this, Google Analytics will report it here. You can also get these numbers split up by browser, by operating system. So this is just a view I made of browser and operating system. Here you can see Safari on iOS is considerably slower on page load time than the rest. And I think that's mostly because it's on a mobile network, whereas nearly all these others are desktop on Wi-Fi. Speed Curve is a really cool site. It's still in private beta right now, but it's hoping to kind of give you a lot more insight when it comes to the performance of your site over time. And so here is HTML5 Rocks, which I work on, plotted against Amazon and TripAdvisor to kind of see that. But one tool that I really want to show is Web Page Test. And I'm going to show it with a site called Retail Me Not. This page I just loaded now. I'm going to do a shift refresh because it's so fast. The developers behind this worked quite a bit on the page load time, and it really shows. But what's really cool is taking a look at what Web Page Test tells us. So I ran this just earlier today. So we did, this is Retail Me Not, assuming a cable internet connection inside Chrome. And so here, if you've seen Web Page Test before, it's been around for a while. You might know it like has the waterfalls and stuff. It has a lot more than that. I really encourage you to take another look. First thing I'm going to show is the film strip view. So over here in the film strip view, we have, just like before, every 100 milliseconds we have a snapshot of what the page looks like. And you can see at 0.9 seconds, we start to have an actual page being rendered. It's really cool as I scroll through this, you can see my waterfall. We're kind of going through my network waterfall, and we're seeing that correlation. Now, another really nice thing is that you can ask Web Page Test to capture the DevTools timeline recording. And so we can just view the DevTools timeline associated with this. So I'm just going to do that right now. So Chrome DevTools is a web app, as you know. So we're just viewing this as a web app. And this is the actual recording that we were looking at on Web Page Test. And we can see a lot more. So we can see here's the data coming in, the HTML, Google Analytics causes a layout. They're asking for an offset width, so to get the screen size. And we come down here, and pretty soon we get a paint. And so this is that paint. It's at 818 milliseconds. That's why we were seeing a thumbnail right then. The last thing I'll show is that it even takes those numbers from the timeline and aggregates them over the load of the page. So we can actually see for that entire duration that it was recording, let's summarize all the time that it spent in layout, in JavaScript, in Paint. And so we can see here, for that page load time, where was the browser spending its time? So here, we're mostly spending a lot of time in JavaScript, to be honest. But layout does contribute a little bit to this. All right, so Web Page Test, really cool. Had a lot of features recently. And the nice thing is that you can take the difference between multiple recordings and be able to track your performance over time. If you do want to use this, the site, if you use webpagetest.org, the site has to be, the site you're testing has to be online, but you can run a private instance, so you can run against a development server if you want. It's all open source. All right, so to sum up, a few things. We heard a lot of numbers tonight. Under 16 milliseconds is smooth animation. Under 100 milliseconds feels pretty much instant. Under 1 second, I'm OK with it. Over a millisecond, users are unhappy. So here are some aggressive but good goals and things that we should really be striving towards. When it comes to mobile connectivity, it is hard to deliver things fast, but users get really impatient quite fast. Shoot to show the content that's above the fold in under a second. One important part of this is serving the above the fold content in the first 14 kilobytes of the response. This includes the CSS that you need to render everything that's above the fold. You can defer the rest of the CSS later on. You don't need it just yet. But fit it in that first 14 kilobytes. That number is not totally magic. It's based off of how TCP slow start works. That's the first time that you're really going to get a considerable amount of data back. Maximum of 200 millisecond server response time, 60 FPS on scrolling, 60 FPS on transitions, and a speed index of under 1,000 would be pretty good. So aside from reaching those goals, which are hefty but good, what can you do? I think it's hard to kind of work on, it seems, talking to the people that I do, a lot of people explain that it's hard to kind of make the case to work on performance. You got to ship features, you got to get that out the door, people expect the end result. And I think we really need to be able to make the case that performance is incredibly important. And the best way to do that is you can show them the numbers from Google and Amazon and Microsoft and anyone who has said that it affects the bottom line significantly. But I think most people really want to see it with their own site, with their own data. So find in your own analytics ways to correlate performance wins to actual business wins that they care about. So maybe the speed index correlated to conversion rate. People that are experiencing your site faster are performing better. Make the case to your client that performance often might trump their feature request. That awesome, cool feature that the user will find once they register for your site probably won't get to that if they're waiting 10 seconds for the site to load. Set up infrastructure to track your perf so you can identify over the development of the project if you're regressing performance or if it's improving. And to be honest, there's some tools available. Like I showed some of them tonight, but I think it's still quite early in the space. And the open source community could use a lot more to kind of help everyone track this stuff better. So I encourage you to join a project or start a new project to help everyone in this area. All right, thanks everyone. Stick around. We're going to do Q&A in a little bit. Thank you. Thanks, Vanessa. Thank you very much. Wow.
All right. So we need a couple minutes to set up the Q&A panel. You can get up for a little bit. We probably call back in about 7 minutes or so, and then have everyone back up here for the Q&A. At around 9:30, 9:35, we'll start with that raffle. There's still some wine in the back. I think the beer is almost gone. And we'll just reset, and we'll be right back.
Yeah.
All right, let's make our way up to the front. Gonna get started for the Q&A session. Really? No, that's a terrible idea. Yeah, let's. Okay, guys. All right, so Q&A time. And if those of you in the back that are not participating, maybe just go a little bit in a quieter area in the very back. Right, that's the problem. All right. Hey everybody. Hey everybody, can we get the noise down in the back a little bit so everyone can? Yeah, thank you. All right. So, who's got a question? I have a mic for you coming your way. We're going to pass this mic around. We'll repeat the question here from the expert panel.
Take it, Jake. Take it. Jake, take it. The word expert feels wrong.
Expert.
Yeah. Yep.
All right. Actually, my question was for Jake.
Oh.
The last one. So first thing is really every time I use the Chrome DevTools, they seem to have improved. So it's really nice. The features you show are really amazing. It's really great. But I still have one concern about the whole thing. Is that I'm kind of concerned about the fact you say in the talk, like if it's slow, use translate
So the question. All right. So the question is, why are you saying use something like translate Z when for something it could be an anti-pattern or it could just be misused? Fair question. Cool. All right. So I think so firstly, what we always say is profile your stuff. Learn to use profilers. Okay. If you start just applying rules that you've heard secondhand, it will work some of the time. It may not work in others, and it may just be a complete disaster. So firstly, learn to profile. What I've been saying recently is that when you write code, you should expect it to work according to the spec. But as Jake pointed out, loads of stuff isn't actually spec'd. And so to get great performance, sometimes you have to understand the implementation of the specification. It's a reality of what we do. And that's okay. Yeah, we should just accept that. We're growing up as an industry. We're doing more, and we're going to have to understand more. It's a slightly uncomfortable thing. There are always people who will just apply stuff and make a mess of it. And we'd much rather learn to profile and figure that stuff out. But right now, this is the way to get past the problem. We'd rather you didn't have the problem. We're always working to try and find better ways of doing Chrome so that we don't have these problems. But you know, we just it's a case of saying, look, if you need to work around this problem, here's a way to do it. We're looking at ways from our side as well to make that happen. So is that fair?
Although I think that there is a lot of validity in what you're saying. Like the advice that we can give today might not work tomorrow. I mean, an example of this would be, I mean, we used to give advice like, if you're going to concatenate a string, don't use plus, right? That'd be insane. No, use an array and then join the array at the end. And that was faster at the time, but now it is slower than just doing a normal string concatenation. But yeah. So these are tips that today will make your shit really fast. But you need to be on top of that. You need to be sort of checking it tomorrow. You know, look after your site. If a new browser comes along that does something different, and mobile especially, you know, can't handle a lot of layers, then yeah, profile it. And if it's not helping, do something different. Okay, so, repeat the question. Would you recommend using HTML5 offline on a new project? If by HTML5 offline we mean application cache, if it's a single-page app, then you could probably get away with it. But if you have URLs, which the web should, then you're probably going to get a lot of pain trying to do that. But we're working on a new thing, right? We've got this navigation controller where you... Service worker. Well, we'll change the name again. Don't worry about it. Don't try and remember anything. Yeah, thanks. But the idea is that you're going to have this web worker that is going to be able to receive events. And one of those events is going to be fetch, when the browser tries to go away and fetch something from the network. And you can cancel that event in the same way you can cancel a click on a link. And you can do something else, which could mean like pull something from a cache or make up a response and serve it. So yeah, and you're right. The native apps, they kind of serve something from the cache straight away and then go and look for an update. And that's the model we're promoting. I've been kind of banging on about progressive enhancement for a while. But this is the next step of that. We're going to treat the network as an enhancement that might not be present. So yeah, that's what you would do. Have the native app model, serve stuff that's there, and then make an extra request for updated data and let that fail silently, and that will be your offline experience.
Okay, we've got a question. I'm a little new, so not that I didn't love the analogy with the pirates, but can you do like a brief summary and
Excellent, sir.
we can do the prevent garbage collection and
garbage collection.
Yeah, absolutely. So it all comes down to this, is that garbage collection events only kick off when there's unreferenced objects sitting around in your memory heap. So you allocate an object, you dereference it, and it's sitting around. This is going to happen over time. You're just going to continue to do this. At some time, you won't be able to control it. It'll happen randomly. The garbage collector will decide it's time to take 10 milliseconds of your frame. It'll stop, it'll do some work, it'll clear out your unreferenced objects, and then it'll give control back to you. This will eat your frame rate. Now, it won't eat the frame rate equally across every app. So I think what we were trying to say earlier was tools, not rules, right? Which means take everything we say up here with a grain of salt against whatever you're profiling. So the whole point of my talk was to talk about don't let your objects die, and it'll keep your GC from actually running, which means you actually have to manage the memory yourself. This is something I've been harping on JavaScript developers for almost a year now, is quit being JavaScript developers. Start looking back towards the trends you see in C and C++, because those patterns of writing code actually result in very, very fast JavaScript execution. So sorry for everyone in here who doesn't agree with that.
You've got the microphone there.
Okay, so we have a lot of really good profiling tools in a desktop environment.
Yeah, he's going to ask about mobile.
For profiling in a mobile environment that's real, not emulated, but real.
Yeah, so everything that we showed today in the Chrome developer tools works. All of that works against Chrome on Android. So all of it. So the memory management stuff. I didn't show the frame rate meter, but the frame rate meter also shows you your available GPU memory and how much is currently being consumed, which gets really interesting when you are scrolling images into view and out of view, and images are being decoded into memory and not. And so Chrome on Android has extremely extensive developer tools. Firefox does as well, and Mobile Safari does now as well. So really the only browser that does not have good tooling is the legacy Android browser and the web view. But as far as dealing with that, I mean, so your options are you have Winery, and you don't have a lot of the performance tooling, but pretty much, you can extrapolate the performance of Android browser based on the sort of performance tools that you're using inside Chrome. So debugging Chrome on Android, all the improvements that you make will have huge impacts in the Android browser.
One thing that I think it does touch on is you still need the device. And this remains a challenge that you can't emulate the GPU of a mobile device from a desktop device. It's just not the same thing. It's not got the same drivers. It's just not the same thing. That remains a challenge. I don't think there's a good answer yet, other than have the device that you're trying to ship for on your desk, test it against that, profile in that. You may have a lot of devices, ultimately, but there isn't a shortcut to that process. I mean, you can get really far just using Chrome DevTools against a decent Nexus device, for example. You can do that, and you can get pretty far, and you can extrapolate, as Paul said, but you might need to just get specific devices.
It is worth pointing out there's a fantastic blog post out there that shows with a Nexus 10 device, you can actually emulate different frequencies and patterns, and you're actually able to emulate a whole swath of different performance profiles with a single item, including different resolutions and whatnot. So find that post on G+.
I'm just going to throw in that I have seen bugs very specifically on certain handsets for the GPU that didn't manifest themselves on anything other than very specific hardware. So sometimes you're just going to have to buy it.
I haven't said anything for this question, and I'm feeling left out. So,
Thanks for some great performance tips. I think this goes for Louis. I think you showed some examples of that I, as a developer, as a front-end guy, I need to combine request animation frame and a scroll handler and an event handler, and I need to combine some positions, I need to remove some class. If I'm scrolling, I need to have good performance. I think that's a lot of complexity to add on each individual front-end developer in this room, that I need to figure out, okay, I'm scrolling, so I should probably remove a class so I don't have transitions.
Right.
Do you think that's a problem, or are we looking into
Yeah, the tools should tell you. I think the question is okay. Dealing with this performance stuff like scrolling, getting fast scrolling, adds a lot of complexity for developers. Is that a good thing, bad thing, evil, happy, smile, smile? No. As I said, I think first of all, again, it's like a tools thing. If you don't have this problem, don't worry about it. If you do have a bottleneck, you want to solve it. You should expect scrolling. You should expect the browser to work if you play the cards right. You should expect the browser to do the right thing. You shouldn't expect fast performance. You have to understand the implementation today. That gap will close over time as the implementation gets better, but it doesn't remove a developer's responsibility to understand the system they're programming for.
Thank you.
I try. Where that line is, I think the thing that personally frustrates me is how easy it is for you to shoot yourself in the foot today. I would love for it to be impossible for you to shoot yourself in the foot. I would. But I don't think that's going to happen anytime soon. We're doing everything that we can to make sure that your code runs well. And you can imagine, the web is the most general computing case you can probably think of. Every developer writes code differently that has different problems in different places because you can do pretty much whatever you feel like doing. This is great. This is the brilliance of the web. It's unbounded. But writing something that can interpret unbounded and do it well without you having to step in and go, actually, here's what I meant, Mr. Browser.
That's why my second part of the question was, are we looking into other ways we can annotate this? So, hey, my element's having animations from the scrolling, deprioritize.
Yes. So we've just recently added a show potential scroll bottlenecks checkbox inside DevTools, which is like, it's going to put a box around and go, hey, you have a touch handler here, which for various reasons will get in the way. A mouse wheel handler is very similar. So we're looking at ways where we see these things crop up, that we flag them to you, give you the kind of alert that this might be a thing. And it's kind of a hand-in-hand thing. Hopefully you'll then go, I maybe don't need that there, I'll remove it.
Yeah, I want to make sure we get through all the questions, but I want to say something super angsty because I'm the angry bald one. He's the happy bald one. Let's be very clear. This is a Perf Matters meetup. This is a Perf Matters talk. You're here because you care about performance. You're here because you should own performance, right? The browser will do what the browser is going to do. The spec is going to do what the spec is going to do. You are in charge of your performance. Ye be the master of ye ship, right? And the browsers are going to optimize differently. But dear God, if anyone in this Perf Matters meetup thinks that any other view besides you are responsible for your performance is the right one, I'm sorry, but you're missing the boat here, literally, right? Own your performance. Take pride in it. Perf Matters. Wear it like a badge. Show it to your boss, your wife, your ex-girlfriend who thinks you're not worth anything anymore. Wear the badge. Make it your credence, and you will ship better products. Don't wait for the platform. Don't wait for the browser. Don't wait for the guy sitting next to you. Be the captain of your damn ship. Thank you.
I'm going to add something boring to that, in that part of the standards process is because if you're finding that you're doing these tricks with JavaScript to enhance performance, like adding an element over the top to catch hover events, so you see they're not going down to the CSS. Make noises about that on the standards groups as well, because when we see this common pattern happening loads of times, we can put that directly in CSS and it will be faster still. We saw this with things like query selector all, CSS animations, that kind of thing.
Actually, generally, just let us know if you find something that really sucks from a performance point of view. We love those because we put those in front of engineers. We talk it through with them. We either would say, oh, yeah, you could change your code and that would fix this problem. Or it's something that's like a platform thing that we're trying to fix and fix quickly. So if you find anything that's like just pathologically bad, then just let us know. We would love to see a bug filed against it, and then we've got something to rally around. Okay. All right.
Sums up what you just talked about. The HTML5 Dev Conference introduces things like, hey, spice up your pages with CSS animations. So I actually had a situation where I wanted one button to stand out as the command people should be noticing, and I put it in. And all of a sudden, a couple weeks later, I realized that my CPU's getting eaten up. And so I think to put it
one of the things that we want to do inside the Chrome DevTools is right now the situation is that if you're interested in performance, you profile, you look at the results, you interpret them, and you make changes. And that works. That works extremely well. But it doesn't reach everyone because not everyone asks the question, why am I slow? Why is this not great? So one of the things that we want to explore is being a bit more proactive in our recommendations. So, oh, I noticed that you're not concatenating your JavaScript in production. I noticed that you have paint storms. I noticed that you're layout thrashing for 3 seconds as you're loading the page. And we have abilities to determine this and show that to the user. We're not there yet, but it's something that we definitely want to do.
We've got 2 more questions, and if we can keep them pretty short.
Sorry, really quickly. Using the web page test thing, I think just the performance thing, stuff that happens after the onload event, I think it mostly captures stuff up till there. Does that matter in terms of like loading more network access and stuff after that event? Do you think that matters to like?
I think we've all got an opinion on this one. Apart from
things like search engines and such. I guess it's also used as such.
I don't think I understand it.
No, I don't think now you've added the search engine thing.
Could you repeat? Because we're not exactly sure.
Do you mean our search engine is going to penalize you for extra loading after onload?
Yeah, exactly. Because like the web page test mostly does until that point.
Okay. So on web page test, the definition of fully rendered for web page test is 2 seconds of idle network activity after window unload. So it basically looks at the network waterfall, make sure that the network activity is still, and that the page is done, and that is how they determine doneness, which seems like a reasonable thing. Search engines are pretty okay with that too.
Yeah, if it's a great user experience for you to get to first render really quickly, but then use the network to cache stuff for the next page or start loading something further down the page, do that. Don't do something else because you think it's going to get you a better rank on Google, because ultimately Google is going to change how it works, how it search indexes based on what gives the best user experience. So never try and game it.
Sort of related. If you kind of every time you do the progressive enhancement thing, and you say you load the page, and then you run some JavaScript that injects something else into the page, and then you do some Ajax, and you put something else into the page, just out of interest, just remember that you're paying the tax every time you do that, because you're going to have to layout, well, recalc style, layout. Actually, you're going to parse HTML, recalc style, layout, paint, and composite for each one of those things, just in the process of loading. So there's a real balancing act here that it's not a one-size-fits-all, right? You want to get stuff on screen quickly, but if you keep nudging things along, you're going to pay that tax several times over. So it's just profile it, figure out what your metrics are for winning, yay, and then go there. Are we on the last question?
Okay, I guess we have 2 final quick questions.
Yes.
Quick answers.
Sweet. I'll answer in 10 words.
Isn't your object pool going to have to be pretty specialized and not clobber hidden classes? And also, isn't the GC time proportional to the number of live objects, especially market suite? So would your market suite be super, super long if you happen to trigger one?
Yes, you should have object pools that are unique to class-specific data. I generally disagree that you should write JavaScript with heterogeneous types in it, right? Like you should have an object and duplicates of that are heterogeneous. I don't believe in having, again, that's my C++ background. And yes, mark and sweep is fantastic, and the iterational garbage collector in V8 is probably one of the most cutting edge you'll find anywhere in the industry. However, you still lose time. And we can sit here and debate all day about the micro optimizations. Go to the tools, go to the tools, go to the tools.
So you talk about pre-allocating your memory, and that's the memory that you can control, like all your JavaScript objects. What about the stuff you can't control, like images floating in and out of view? I know in something I'm working on at the moment, I have very little JavaScript getting allocated, but it just ramps up and GC drops
That's a fantastic question for people who didn't hear that on the live stream. Can you control the garbage collection of things that aren't JavaScript created objects, images, DOMs, and stuff like that? So we could sit down and profile your whole site and give you a million different ways to handle this. The short answer is yes, if you're willing to be super tricky. For instance, objects will come down off the network and images will be created. You can't fix that. That's under the hood. But how it's resident in your memory on the page, for example, having a static pool of 10 canvases, right? And then swapping and managing in how those canvases are filled as sprite sheets and how the UV coordinates on that is handled could definitely be a potential solution for that would cut down a lot of your texture memory residency there. So hundreds of different, thousands of different things, depending on all of your use cases. Again, this comes back to it, right?
You can talk about that. I think in general, something like the image one very specifically, we're working really hard. There are loads of optimizations that we feel that we can make in terms of image decoding and image resizing in the pipeline. When you see them crop up in DevTools and you see these huge green spikes of paint and you see a little arrow and you're like, I know what's inside this. You spin it and it goes, image decode, image resize. And you're like, yeah, I knew that was coming. And we want that to we want that to be a complete non-issue, right? We just want it to go away. We have ideas. The engineers are looking at it. It's a thing, right? So we want it to go away. In the short term, it's about avoiding resize, like we said before. It's about doing all you can to mitigate it. But it's just one of these things that is hopefully going to get better over time. We know it's a thing. We want it to be better. But there isn't. You can go crazy and do the canvas thing. I did that. It's weird.
But it works.
It works. It works. But you just go so far off road. You understand it. The browser does it for you for a reason.
Yeah. Okay. Can I say something?
No, Peter's going to take it away.
No.
Don't give it to him. Don't give it to him.
The guy who scored really well on the quiz that I did, I owe you swag. Yeah, come up to the front and you'll get swag. Brilliant. In a minute. I'll stay here, right?
Super awkward.
Yeah.
You just came up here and we're like, hey.
I'll present you it.
Yes.
All right. Well, one more time, a big round of applause for these great speakers. Thank you. Thank you. Everybody on the live stream, we had over 200 people on the live stream watching, which was great. Everybody, thanks for joining. And it was one of the longest average view time, like 25 minutes per person. So that was awesome. So thanks for joining us. All of these talks will be recorded. Well, they were recorded, but they will be posted on our site shortly on the Google Developers Live site as well. And yeah, and we'd like your feedback. So if there's on the Meetup site, when you're done, you're probably going to get an email seeing if you can give a rating. Let us know your feedback. We're always open to making changes for the better. So hope you enjoyed it. And we're going to say goodbye to the live stream and move on to the raffle here. Thank you.